Imagine a world where information is flowing like a vast river. Every second, this river is creating a huge amount of data, like tiny droplets, and we are trying to catch and understand all of them. Well, that's what big data is all about. Big data offers a wealth of valuable insights, enables real-time and predictive analytics, and significantly impact industries such as healthcare, smart cities, social media, and security. Its potential and applications constantly expand as technology progresses and more data becomes accessible for analysis. Big data is a powerful tool that allows us to make sense of the overwhelming amount of information in our digital world. It's like having a secret codebook that unlocks the hidden treasures of knowledge, empowering us to make smarter decisions and explore new boundaries. Big data presents various career opportunities, including roles such as data analyst, data scientist, data engineer, BI analyst, DB administrator, and architecture. This position demands a diverse skill set, including data analysis, machine learning, programming, and database management. According to Glassdoor, the average annual salary for a big data engineer in the United States is approximately $120,000. In India, the average salary for this role is 8 lakh per annum. On that note, hey learners, Simplilearn offers you a postgraduate program in data engineering, developed in collaboration with Purdue University and IBM, which provides an excellent opportunity for professional growth. With a curriculum aligned with AWS and Azure certification, this hands-on learning experience equips participants with essential data engineering skills. Don't miss out on the opportunity to enhance your data skills through our cutting-edge Big Data Engineer course offered by Simplilearn. Do check out the course link in the description for more details. Before we begin, let's take a minute to hear from our learners who have experienced huge success in their career.
The learning from Simplilearn has been really amazing and extremely helpful. Whoever is watching this video, I recommend you go out to Simplilearn's website and check out their courses. They have brilliant instructors who are industry-wide solution architects and directors working at the biggest firms right now. Hi, my name is Aditya and I'm working as a consultant in Atos in the field of AI, machine learning and RPA. I did my engineering from Maharaja Surajmal Institute of Technology. I majored in electronics and communication engineering. I passed out in 2013 and on campus I got placed into a company called Nucleus Software. So I started working in software engineering team. The team was involved into application development using Oracle Forms, SQL and database languages. I wanted to explore better technologies which were there in the market at that time. I got to know that machine learning and big data, they revolve around SQL. So if you are a SQL person, you are very much comfortable with learning new machine learning techniques and database technologies like big data, Hadoop. So that's when I started looking out for the training institutes, and then my relative referred me. Once I decided to go for Simplilearn, I had one course in my mind which was big data only. But when I approached Simplilearn, they offered me a bundle of courses in one master program, which included not only big data, but also machine learning and Python basics, R basics, data science with Python, and some Java fundamentals as well. So that was really good to have. What I liked most about the training was the context of the training as well as the instructor to student engagement. After the training, I got an opportunity to learn more about these technologies, and once I was done learning, I attended a lot of interviews. So they were in some big MNCs, and the interviewers were real life big data architects and data science experts, and they were really happy to see the knowledge which I have. So Simplilearn definitely set up a base for me on that, and once I started giving interviews, eventually I landed up in a MNC in Chennai where I'm working as a data science expert and a consultant. Simplilearn's Big Data Master Program helped me to get a new job with a very good salary hike. A very big thanks to Simplilearn for making me who I am. I feel really fortunate to be associated with these technologies. Now I can lead different teams and drive different business transformation programs using my skill set. I really wanted to upskill because in the market and in the IT industry, upskilling is really important.
So, without any further delay, let's begin by understanding the basics of big data.
We all use smartphones, but have you ever wondered how much data it generates in the form of texts, phone calls, emails, photos, videos, searches, and music? Approximately 40 exabytes of data gets generated every month by a single smartphone user. Now, imagine this number multiplied by 5 billion smartphone users. That's a lot for our mind to even process, isn't it? In fact, this amount of data is quite a lot for traditional computing systems to handle. And this massive amount of data is what we term as big data. Let's have a look at the data generated per minute on the internet. 2.1 million snaps are shared on Snapchat. 3.8 million search queries are made on Google. 1 million people log on to Facebook. 4.5 million videos are watched on YouTube. 188 million emails are sent. That's a lot of data. So, how do you classify any data as big data? This is possible with the concept of 5 V's: volume, velocity, variety, veracity, and value. Let us understand this with an example from the healthcare industry. Hospitals and clinics across the world generate massive volumes of data. 2,314 exabytes of data are collected annually in the form of patient records and test results. All this data is generated at a very high speed, which attributes to the velocity of big data. Variety refers to the various data types, such as structured, semi-structured, and unstructured data. Examples include Excel records, log files, and X-ray images. Accuracy and trustworthiness of the generated data is termed as veracity. Analyzing all this data will benefit the medical sector by enabling faster disease detection, better treatment, and reduced cost. This is known as the value of big data. But how do we store and process this big data? To do this job, we have various frameworks such as Cassandra, Hadoop, and Spark. Let us take Hadoop as an example and see how Hadoop stores and processes big data. Hadoop uses a distributed file system known as Hadoop Distributed File System to store big data. If you have a huge file, your file will be broken down into smaller chunks and stored in various machines. Not only that, when you break the file, you also make copies of it, which goes into different nodes. This way, you store your big data in a distributed way and make sure that even if one machine fails, your data is safe on another. MapReduce technique is used to process big data. A lengthy task A is broken into smaller tasks, B, C, and D. Now, instead of one machine, 3 machines take up each task and complete it in a parallel fashion and assemble the results at the end. Thanks to this, the processing becomes easy and fast. This is known as parallel processing. Now that we have stored and processed our big data, we can analyze this data for numerous applications. In games like Halo 3 and Call of Duty, designers analyze user data to understand at which stage most of the users pause, restart, or quit playing. This insight can help them rework on the storyline of the game and improve the user experience, which in turn reduces the customer churn rate. Similarly, big data also helped with disaster management during Hurricane Sandy in 2012. It was used to gain a better understanding of the storm's effect on the east coast of the U.S., and necessary measures were taken. It could predict the hurricane's landfall 5 days in advance, which wasn't possible earlier. These are some of the clear indications of how valuable big data can be once it is accurately processed and analyzed.
Big data is a term for data sets that cannot be handled by traditional computers or tools due to their value, volume, velocity, and veracity. It is defined as massive amount of data which cannot be stored, processed, and analyzed using various traditional methods. Do you know how much data is being generated every day, every second? Even as I talk right now, there are millions of data sources which generate data at a very rapid rate. These data sources are present across the world. As you know, social media sites generate a lot of data. Let's take an example of Facebook. Facebook generates over 500 plus terabytes of data every day. This data is mainly generated in terms of your photographs, videos, messages, etc. Big data also contains data of different formats like structured data, semi-structured data, and unstructured data. Data like your Excel sheets all fall under structured data. This data has a definite format. Your emails fall under semi-structured and your pictures and videos all fall under unstructured data. All this data together make up for big data. It is very tough to store, process, and analyze big data using RDBMS. If you have looked into our previous videos, you would know that Hadoop is the solution to this. Hadoop is a framework that stores and processes big data. It stores big data using the distributed storage system, and it processes big data using the parallel processing method. Hence, storing and processing big data is no more a problem using Hadoop. Big data in its raw form is of no use to us. We must try to derive meaningful information from it in order to benefit from this big data. Do you know Amazon uses big data to monitor its items that are in its fulfillment centers across the globe? How do you think Amazon does this? Well, it is done by analyzing big data, which is known as big data analytics. What is big data analytics? In simple terms, big data analytics is defined as the process which is used to extract meaningful information from big data. This information could be your hidden patterns, unknown correlations, market trends, and so on. By using big data analytics, there are many advantages. It can be used for better decision making, to prevent fraudulent activities, and many others. We will look into 4 of them step by step. I will first start off with big data analytics, which is used for risk management. BDO, which is a Philippine banking company, uses big data analytics for risk management. Risk management is an important aspect for any organization, especially in the field of banking. Risk management analysis comprises a series of measures which are employed to prevent any sort of unauthorized activities. Identifying fraudulent activities was a main concern for BDO. It was difficult for the bank to identify the fraudster from a long list of suspects. BDO adopted big data analytics, which helped the bank to narrow down the entire list of suspects. Thus, the organization was able to identify the fraudster in a very short time. This is how big data analytics is used in the field of banking for risk management. Let us now see how big data analytics is used for product development and innovations with an example. All of you are aware of Rolls-Royce cars, right? Do you also know that they manufacture jet engines which are used across the world? What is more interesting is that they use big data analytics for developing and innovating this engine. A new product is always developed by trial and error method. Big data analytics is used here to analyze if an engine design is good or bad. It is also used to analyze if there can be more scope for improvement based on the previous models and on the future demands. This way, big data analytics is used in designing a product which is of higher quality. Using big data analytics, the company can save a lot of time. If the team is struggling to arrive at the right conclusion, big data can be used to zero in on the right data which have to be studied, and thus the time spent on the product development is less. Big data analytics helps in quicker and better decision making in organizations. The process of selecting a course of action from various other alternatives is known as decision making. Lot of organizations take important decisions based on the data that they have. Data-driven business decisions can make or break a company. Hence, it is important to analyze all the possibilities thoroughly and quickly before making important decisions. Let us now try to understand this with an use case. Starbucks uses big data analytics for making important decisions. They decide the location of their new outlet using big data analytics. Choosing the right location is an important factor for any organization. The wrong location will not be able to attract the required amount of customers. Positioning of a new outlet a few miles here or there can always make a huge difference for an outlet, especially a one like Starbucks. Various factors are involved in choosing the right location for a new outlet. For example, parking adequacy has to be taken into consideration. It would be inconvenient for people to go to a store which has no parking facility. Similarly, the other factors that have to be considered are the visibility of the location, the accessibility, the economic factors, the population of that particular location, and also we would have to look into the competition in the vicinity. All these factors have to be thoroughly analyzed before making a decision as to where the new outlet must be started. Without analyzing these factors, it would be impossible for us to make a wise decision. Using big data analytics, we can consider all these factors and analyze them quickly and thoroughly. Thus, Starbucks makes use of big data analytics to understand if their new location would be fruitful or not. Finally, we will look into how big data analytics is used to improve customer experience using an example. Delta, an American airline, uses big data analytics to improve its customer experiences. With the increase in global air travel, it is necessary that an airline does everything they can in order to provide good service and experience to its customers. Delta Airlines improves its customer experience by making use of big data analytics. This is done by monitoring tweets, which will give them an idea as to how their customer's journey was. If the airline comes across a negative tweet and if it is found to be the airline's fault, the airline goes ahead and upgrades that particular customer's ticket. When this happens, the customer is able to trust the airlines, and without a doubt, the customer will choose Delta for their next journey. By doing so, the customer is happy and the airlines will be able to build a good brand recognition. Thus, we see here that by using analysis, Delta Airlines was able to improve its customer experience. Moving on to our next topic, that is life cycle of big data analytics. Here we will look into the various stages as to how data is analyzed from scratch. The first stage is the business case evaluation stage. Here, the motive behind the analysis is identified. We need to understand why we are analyzing so that we know how to do it and what are the different parameters that have to be looked into. Once this is done, it is clear for us and it becomes much easier for us to proceed with the rest. After which, we will look into the various data sources from where we can gather all the data which will be required for analysis. Once we get the required data, we will have to see if the data that we received is fit for analysis or not. Not all the data that we receive will have meaningful information. Some of it will surely just be corrupt data. To remove this corrupt data, we will pass this entire data through a filtering stage. In this stage, all the corrupt data will be removed. Now we have the data minus the corrupt data. Do you think our data is now fit for analysis? Well, it is not. We still have to figure out which data will be compatible with the tool that we will be using for analysis. If we find data which is incompatible, we first extract it and then transform it to a compatible form depending on the tool that we use. In the next stage, all the data with the same fields will be integrated. This is known as the data aggregation stage. The next stage, which is the analysis stage, is a very important stage in the life cycle of big data analytics. Right here in this step, the entire process of evaluating your data using various analytical and statistical tools to discover meaningful information is done. Like we've discussed before, the entire process of deriving meaningful information from data, which is known as analysis, is done here in this stage. The result of the data analysis stage is then graphically communicated using tools like Tableau, Power BI, ClickView. This analysis result will then be made available to different business stakeholders for various decision making. This was the entire life cycle of big data analytics. We just saw how data is analyzed from scratch. Now we will move on to a very important topic, that is the different types of big data analytics. Well, we have 4 different types of big data analytics. As you see here, these are the types, and below this are the questions that each type tries to answer. We have descriptive analytics, which asks the question, what has happened? Then we have diagnostic analytics, which asks, why did it happen? Predictive analytics, asking what will happen? And prescriptive analytics, which questions by asking what is the solution. We will look into all these 4 one by one with an use case for each. We will first start off with descriptive analytics. As mentioned earlier, descriptive analytics asks the question what has happened. It can be defined as the type that summarizes past data into a form that can be understood by humans. In this type, we will look into the past data and arrive at various conclusions. For example, an organization can review its performance using descriptive analytics. That is, it analyzes its past data such as revenue over the years and arrives at a conclusion with the profit. By looking at this graph, we can understand if the company is running at a profit or not. Thus, descriptive analytics helps us understand this easily. We can simply say that descriptive analytics is used for creating various reports for companies and also for tabulating various social media metrics like Facebook likes, tweets, etc. Now that we have seen what is descriptive analytics, let us look into an use case of descriptive analytics. The Dow Chemical Company analyzed all its past data using descriptive analytics, and by doing so, they were able to identify the underutilized space in their facility. Descriptive analytics helped them in this space consolidation. On the whole, the company was able to save nearly $4 million annually. So we now see here that descriptive analytics not only helps us derive meaningful information from the past data, but it can also help companies in cost reduction if it is used wisely. Let us now move on to our next type, that is diagnostic analytics. Diagnostic analytics asks the question why a particular problem has occurred. As you can see, it will always ask the question why did it happen? It will look into the root cause of a problem and try to understand why it has occurred. Diagnostic analytics makes use of various techniques such as data mining, data discovery, and drill down. Companies benefit from this type of analytics because it helps them look into the root cause of a problem. By doing so, the next time the same problem will not arise, as the company already knows why it has happened and they will arrive at a particular solution for it. iNetsoft's BI query tool is an example of diagnostic analytics. We can use query tool for diagnostic analytics. Now that you know why diagnostic analytics is required and what diagnostic analytics is, I will run you through an example which shows where diagnostic analytics can be used. All of us shop on e-commerce sites, right? Have you ever added items to your cart but ended up not buying it? Yes, all of us might have done that at some point. An organization tries to understand why its customers don't end up buying their products although it has been added to their carts. And this understanding is done with the help of diagnostic analytics. An e-commerce site wonders why they have made few online sales although they have had a very good marketing strategy. There could have been various factors as to why this has happened. Factors like the shipping fee which was too high, or the page that didn't load correctly, not enough payment options available, and so on. All these factors are analyzed using diagnostic analytics and the company comes to a conclusion as to why this has happened. Thus, we see here that the root cause is identified so that in future the same problem doesn't occur again. Let us now move on to the third type, that is predictive analytics. As the name suggests, predictive analytics makes predictions of the future. It analyzes the current and historical facts to make predictions about future. It always asks the question what will happen next. Predictive analytics is used with the help of artificial intelligence, machine learning, data mining to analyze the data. It can be used for predicting customer trends, market trends, customer behavior, etc. It solely works on probability. It always tries to understand what can happen next with the help of all the past and current information. A company like PayPal, which has 260 plus million accounts, always has the need to ensure that their online fraudulent and unauthorized activities are brought down to nil. Fear of constant fraudulent activities have always been a major concern for PayPal. When a fraudulent activity occurs, people lose trust in the company, and this brings in a very bad name for the brand. It is inevitable that fraudulent activities will happen in a company like PayPal, which is one of the largest online payment processors in the world. But PayPal uses analytics wisely here to prevent such fraudulent activities and to minimize them. It uses predictive analytics to do so. The organization is able to analyze past data, which includes a customer's historical payment data, a customer's behavior trend, and then it builds an algorithm which works on predicting what is likely to happen next with respect to their transaction. With the use of big data and algorithms, the system can gauge which of the transactions are valid and which could be potentially a fraudulent activity. By doing so, PayPal is always ready with precautions that they have to take to protect all their clients against fraudulent transactions. We will now move on to our last type, that is prescriptive analytics. Prescriptive analytics, as the name suggests, always prescribes a solution to a particular problem. The problem can be something which is happening currently. Hence, it can be termed as the type that always asks the question, what is the solution? Prescriptive analytics is related to both predictive and descriptive analytics. As we saw earlier, descriptive analytics always asks the question, what has happened? And predictive analytics helps you understand what can happen next. With the help of artificial intelligence and machine learning, prescriptive analytics helps you arrive at the best solution for a particular problem. Various business rules, algorithms, and computational modeling procedures are used in prescriptive analytics. Let us now have a look at how and where prescriptive analytics is used with an example. Here we will understand how prescriptive analytics is used by an airline for its profit. Do you know that when you book a flight ticket, the price of it depends on various factors, both internal and external factors. Apart from taxes, seat selection, there are other factors like oil prices, customer demand, which are all taken into consideration before the flight's fare is displayed. Prices change due to availability and demand. Holiday seasons are a time when the rates are much higher than the normal days. Seasons like Christmas and school vacations, also weekends, the rates will be much higher than weekdays. Another factor which determines a flight's fare is your destination. Depending on the place where you are traveling to, the flight fare will be adjusted accordingly. This is because there are quite a few places where the air traffic is less, and in such places the flight's fare will also be less. So prescriptive analytics analyzes all these factors that are discussed, and it builds an algorithm which will automatically adjust a flight's fare. By doing so, the airline is able to maximize its profit. These were the 4 types of analytics. Now let us understand how we achieve these with the use of big data tools. Our next topic will be the various tools used in big data analytics. These are a few of the tools that I will be talking about today. We have Hadoop, MongoDB, Talend, Kafka, Cassandra, Spark, and Storm. We will look into each one of them one by one. We will first start off with Hadoop. When you speak of big data, the first framework that comes into everyone's mind is Hadoop, isn't it? As I mentioned earlier, Apache Hadoop is used to store and process big data in a distributed and parallel fashion. It allows us to process data very fast. Hadoop uses MapReduce, Pig, and Hive for analyzing this big data. Hadoop is easily one of the most famous big data tools. Now let us move on to the next one, that is MongoDB. MongoDB is a cross-platform, document-oriented database. It has the ability to deal with large amount of unstructured data. Processing of data which is unstructured and processing of data sets that change very frequently is done using MongoDB. Talend provides software and services for data integration, data management, and cloud storage. It specializes in big data integration. Talend Open Studio is a free open source tool for processing data easily on a big data environment. Cassandra is used widely for an effective management of large amounts of data. It is similar to Hadoop in its feature of fault tolerance, where data is automatically replicated to multiple nodes. Cassandra is preferred for real-time processing. Spark is another tool that is used for data processing. This data processing engine is developed to process data way faster than Hadoop MapReduce. This is done in a way because Spark does all the processing in the main memory of the data nodes, and thus it prevents unnecessary input-output overheads with the disk. Whereas MapReduce is disk-based, and hence Spark proves to be faster than Hadoop MapReduce. Storm is a free big data computational system which is done in real time. It is one of the easiest tools for big data analysis. It can be used with any programming language. This feature makes Storm very simple to use. Finally, we will look into another big data tool which is known as Kafka. Kafka is a distributed streaming platform which was developed by LinkedIn and later given to Apache Software Foundation. It is used to provide real-time analytics result, and it is also used for fault-tolerant storage. These were few of the big data analytics tools. Now let us move on to our last topic for today, that is big data application domains. Here we will look into the various sectors where big data analytics is actively used. The first sector is e-commerce. Nearly 45% of the world is online, and they create a lot of data every second. Big data can be used smartly in the field of e-commerce by predicting customer trend, forecasting demands, adjusting the price, and so on. Online retailers have the opportunity to create better shopping experience and generate higher sales if big data analytics is used correctly. Having big data doesn't automatically lead to a better marketing strategy. Meaningful insights need to be derived from it in order to make right decisions. By analyzing big data, we can have personalized marketing campaigns which can result in better and higher sales. In the field of education, depending on the market requirements, new courses are developed. The market requirement needs to be analyzed correctly with respect to the scope of a course, and accordingly a scope needs to be developed. There is no point in developing a course which has no scope in the future. Hence, to analyze the market requirement and to develop new courses, we use big data analytics here. There are a number of uses of big data analytics in the field of healthcare, and one of it is to predict a patient's health issue. That is, with the help of their previous medical history, big data analytics can determine how likely they are to have a particular health issue in the future. The example of Spotify that we saw previously showed how big data analytics is used to provide a personalized recommendation list to all its users. Similarly, in the field of media and entertainment, big data analytics is used to understand the demands of shows, songs, movies, and so on to deliver personalized recommendation lists as we saw with Spotify. Big data analytics is used in the field of banking. As we saw previously with a few use cases, big data analytics was used for risk management. In addition to risk management, it is also used to analyze a customer's income and spend patterns and to help the bank predict if a particular customer is going to choose any of the bank offers such as loans, credit cards, schemes, and so on. This way, the bank is able to identify the right customer who is interested in its offers. It is noticed that telecom companies have begun to embrace big data to gain profit. Big data analytics helps in analyzing network traffic and call data records. It can also improve its service quality and improve its customer experience. Let us now look into how big data analytics is used by governments across the world. In the field of law enforcement, big data analytics can be applied to analyze all the available data to understand crime patterns. Intelligence services can use predictive analytics to forecast the crime which could be committed. In Durham, the police department was able to reduce the crime rate using big data analytics. With the help of data, police could identify whom to target, where to go, when to patrol, and how to investigate crimes. Big data analytics helped them to discover patterns of crime emerging in the area. Before we move on to the applications, let's have a quick look at the big data market revenue forecast worldwide from 2011 to 2027. So here's a graph in which the y-axis represents the revenue in billion US dollars and the x-axis represents the years. As it is seen clearly from the graph, big data has grown until 2019 and statistics predict that this growth will continue even in the future. This growth is made possible as numerous companies use big data in various domains to boost their revenue. We will look into a few of such applications. The first big data application we will look into is weather forecast. Imagine there is a sudden storm and you're not even prepared. That would be a terrifying situation, isn't it? Dealing with any calamities such as hurricanes, storms, floods would be very inconvenient if we are caught off guard. The solution is to have a tool that predicts the weather of the coming days well in advance. This tool needs to be accurate, and to make such a tool, big data is used. So how does big data help here? Well, it allows us to gather all the information required to predict the weather. Information such as the climate change details, wind direction, precipitation, previous weather reports, and so on. After all this data is collected, it becomes easier for us to spot a trend and identify what's going to happen next by analyzing all of this big data. A weather prediction engine works on this analysis. It predicts the weather of every region across the world for any given time. By using such a tool, we can be well prepared to face any climate change or any natural calamity. Let's take an example of a landslide and try to understand how big data is used to tackle such a situation. Predicting a landslide is very difficult with just the basic warning signs. Lack of this prediction can cause a huge damage to life and property. This challenge was studied by the University of Melbourne, and they developed a tool which is capable of predicting a landslide. This tool predicts the boundary where a landslide is likely to occur 2 weeks before. This magical tool works on both big data and applied mathematics. An accurate prediction like this, which is made 2 weeks before, can save lives and help in relocating people in that particular region. It also gives us an insight into the magnitude of the upcoming destruction. This is how big data is used in weather forecast and in predicting any natural calamities across the world. Let us now move on to our next application, that is big data application in the field of media and entertainment. The media and the entertainment industry is a massive one. Leveraging big data here can produce sky-high results and boost the revenue for any company. Let us see the different ways in which big data is used in this industry. Have you ever noticed that you come across relevant advertisements in your social media sites and in your mailboxes? Well, this is done by analyzing all your data, such as your previous browsing history and your purchase data. Publishers then display what you like in the form of ads, which will in turn catch your interest in looking into it. Next up is customer sentiment analysis. Customers are very important for a company. The happier the customer, the greater the company's revenue. Big data helps in gathering all the emotions of a customer through their posts, messages, conversations, etc. These emotions are then analyzed to arrive at a conclusion regarding the customer's satisfaction. If the customer is unhappy, the company strives to do better the next time and provides their customers a better experience. While purchasing an item from an e-commerce site or while watching videos on an entertainment site, you might have noticed a segment which says most recommended list for you. This list is a personalized list which is made available to you by analyzing all the data such as your previous watch history, your subscriptions, your likes, and so on. Recommendation engine is a tool that filters and analyzes all this data and provides you with a list that you would most likely be interested in. By doing so, the site is able to retain and engage its customer for a longer time. Next is customer churn analysis. In simple words, customer churn happens when a customer stops their subscription with a service. Predicting and preventing this is of paramount importance to any organization. By analyzing the behavioral patterns of previously churned customers, an organization can identify which of their current customers are likely to churn. By analyzing all of this data, the organization can then implement effective programs for customer retention. Let us now look into an use case of Starbucks. Big data is effectively used by the Starbucks app. 17 million users use this app, and you can imagine how much data they generate. Data in the form of their coffee buying habits, the store they visit, and to the time they purchase. All of this data is fed into the app. So when a customer enters a new Starbucks location, the system analyzes all their data and they are provided with their preferred order. This app also suggests new products to the customer. In addition to this, they also provide personalized offer and discounts on special occasions. Moving on to our next sector, which is healthcare. It is one of the most important sectors. Big data is widely used here to save lives. With all the available big data, medical researches are done very effectively. They are performed accurately by analyzing all the previous medical histories, and new treatments and medicines are discovered. Cure can be found out even for few of the incurable diseases. There are cases when one medication need not be effective for every patient. Hence, personal care is very important. Personal care is provided to each patient depending on their past medical history. An individual's medical history along with their body parameters are analyzed, and personal attention is given to each of them. As we all know, medical treatments are not very pocket friendly. Every time a medical treatment is taken, the amount increases. This can be reduced if readmissions are brought down. Analyzing all the data precisely will deliver a long-term efficient result, which will in turn prevent a patient's readmission frequently. With globalization came an increase in the ease for infectious diseases to spread widely. Based on geography and demographics, big data helps in predicting where an outbreak of epidemic viruses are most likely to occur. An American healthcare company, United Healthcare, uses big data to detect any online medical fraud activities such as payment of unauthorized benefits, intentional misrepresentation of data, and so on. The healthcare company runs disease management programs. The success rates of these programs are predicted using big data depending on how patients respond to it. The next sector we will look into is logistics. Logistics looks into the process of transportation and storage of goods. The movement of a product from its supplier to a consumer is very important. Big data is used to make this process faster and efficient. The most important factor in logistics is the time taken for the products to reach their destination. To achieve minimum time, sensors within the vehicle analyze the fastest route. This analysis is based on various data such as the weather, traffic, the list of orders, and so on. By doing so, the fastest route is obtained and the delivery time is reduced. Capacity planning is another factor which needs to be taken into consideration. Details regarding the workforce and the number of vehicles are analyzed thoroughly, and each vehicle is allocated a different route. This is done as there is no need for many trucks to travel in the same direction, which will be pointless. Depending on the analysis of the available workforce and resources, this decision is taken. Big data analytics also finds its use in managing warehouses efficiently. This analysis, along with tracking sensors, provide information regarding the underutilized space, which results in efficient resource allocation and eventually reduces the cost. Customer satisfaction is important in logistics just like it is in any other sector. Customer reactions are analyzed from the available data, which will eventually create an instant feedback loop. A happy customer will always help the company gain more customers. Let us now look into a use case of UPS. As you know, UPS is one of the biggest shipping company in the world. They have a huge customer database and they work on data every minute. UPS uses big data to gather different kinds of data regarding the weather, the traffic jams, the geography, the locations, and so on. After collecting all this data, they analyze it to discover the best and the fastest route to the destination. In addition to this, they also use big data to change the routes in real time. This is how efficiently UPS leverages big data. Next up, we have a very interesting sector, that is the travel and tourism sector. The global tourism market is expected to grow in the near future. Big data is used in various ways in this sector. Let us look into a few of them. Hotels can increase their revenue by adjusting the room tariffs depending on the peak seasons, such as holiday seasons, festive seasons, and so on. The tourism industry uses all of this data to anticipate the demand and maximize their revenue. Big data is also used by resorts and hotels to analyze various details details regarding their competitors. This analysis result helps them to incorporate all the good facilities their competitors are providing. And by doing so, the hotel is able to flourish further. A customer always comes back if they are offered good packages which are more than just the basic ones. Looking into a customer's past travel history, likes and preferences, hotels can provide its customers with personalized experiences which will interest them highly. Investing in an area which could be the hub of tourism is very wise. Few countries use big data to examine the tourism activities in their country, and this in turn helps them discover new and fruitful investment opportunities. Let us look into one of the best online homestay networks, Airbnb, and see how big data is used by them. Airbnb undoubtedly provides its customers with the best accommodation across the world. Big data is used by it to analyze the different kinds of available properties. Depending on the customer's preferences, the pricing, the keywords, previous customers, ratings and experiences, Airbnb filters out the best result. Big data works its magic yet again. Now we will move on to our final sector, which is the government and law enforcement sector. Maintaining law and order is of utmost importance to any government. It is a huge task by itself. Big data plays an active role here, and in addition to this, it also helps governments bring in new policies and schemes for the welfare of its citizens. The police department is able to predict criminal activities way before it happens by analyzing big data information such as the previous crime records in a particular region, the safety aspect in that region, and so on. By analyzing these factors, they are able to predict any activity which breaks the law and order of the region. Governments are able to tackle unemployment to a great extent by using big data. By analyzing the number of students graduating every year to the number of relevant job openings, the government can have an idea of the unemployment rate in the country and then take necessary measures to tackle it. Our next factor is poverty. In large countries, it is difficult to analyze which area requires attention and development. Big data analytics makes it easier for governments to discover such areas. Poverty gradually decreases once these areas begin to develop. Governments have to always be on the lookout for better development. A public survey voices the opinion of a country's citizens. Analyzing all the data collected from such surveys can help governments build better policies and services which will benefit its citizens. Let us now move on to our use case. Did you know that the New York Police Department uses big data analytics to protect its citizens? The department prevents and identifies crimes by analyzing a huge amount of data, which includes fingerprints, certain emails, and records from previous police investigations, and so on. After analyzing all of this data, meaningful insights are drawn from it, which will help the police in taking the required preventive measures against crimes.
Now, when we talk about evolution of big data, we have known that data has evolved in last 5 years like never before. Now, in fact, before going to big data or before understanding these solutions and the need and why there is a rush towards big data technology and solution, I would like to ask a question. Take a couple of minutes and think, why are organizations interested in big data? Why is there sudden rush in industry where everyone would want to ramp up their current infrastructure or would want to be working on technologies which allow them to use this big data? Think about it. What is happening and why are organizations interested in this? And if you think on this, you will start thinking about what organizations have been doing in past, what organizations have not done, and why are organizations interested in big data. Now, before we learn on big data, we can always look into internet and check for use cases where organizations have failed to use legacy systems or relational databases to work on their data requirements. Now, over past 5 years or in recent decade, what has happened is organizations have started understanding the value of data, and they have decided not to ignore any data as being uneconomical. Now we can talk about different platforms through which data is generated. Take an example of social media like Twitter, Facebook, Instagram, WhatsApp, YouTube. You have e-commerce and various portals, say eBay, Amazon, Flipkart, Alibaba.com. And then you have various tech giants such as Google, Oracle, SAP, Amazon, Microsoft, and so on. So lots of data is getting generated every day in every business sector. The point here is that organizations have slowly started realizing that they would be interested in working on all the data. Now, the question which I asked was, why are organizations interested in big data? And some of you might have already answered or thought about that organizations are interested in doing precise analysis, or they want to work on different formats of data, such as structured, unstructured, semi-structured data. Organizations are interested in gaining insights or finding the hidden treasure in the so-called big data. And this is the main reason where organizations are interested in big data. Now, there are various use cases. We can compare that organizations from past 50 or more than 50 years have been handling huge amount of data. They have been working on huge volume of data. But the question here is, have they worked on all the data, or have they worked on some portion of it? What have they used to store this data? And if they have used something to store this data, what is happening? What is changing now? When we talk about the businesses, we cannot avoid talking about the dynamism involved. Now, any organization would want to have a solution which allows them to store data and store huge amount of data, capture it, process it, analyze it, and also look into the data to give more value to the data. Organizations have then been looking for solutions. Now let's look at some facts that can convince you, or that would convince you, that data is exploding and needs your attention, right? 55 billion messages and 4.5 billion photos are sent each day on WhatsApp. 300 hours of video are uploaded every minute on YouTube. Did you guys know that YouTube is the second largest search engine after Google? Every minute, users send 31.25 million messages and watch 2.77 million videos on Facebook. Walmart handles more than 1 million customer transactions every hour. Google, 40,000 search queries are performed on Google per second. That is 3.46 million searches a day. In fact, you could also say that a lot of times people, when they are loading up the Google page, is basically just to check their internet connection. However, that is also generating data. IDC reports that by 2025, real-time data will be more than a quarter of all the data. And by 2025, the volume of digital data will increase to 163 zettabytes. That is, we are not even talking about gigabytes or terabytes anymore. We are talking about petabytes, exabytes, and zettabytes. And zettabytes means 10 to the power 21 bytes. So this is how data has evolved. Now you can talk about different companies which would want to use their data to take business decisions. They would want to collect the data, store it, and analyze it. And that's how they would be interested in drawing insights for the business. Now, this is just a simple example about Facebook and what it does to work on the data. Now, before we go to Facebook, you could always check in Google by just typing in companies using big data. And if we say companies using big data, we should be able to find a list of different companies which are using big data for different use cases. There are various sources from where you can find. We could also search for solution, that is Hadoop, which we'll discuss later, but you could always say companies using Hadoop, and that should take you to the wiki page, which will basically help you know what are the different companies which are using this so-called solution called Hadoop. Okay, now coming back to what we were discussing about. So organizations are interested in big data, as we discussed, in gaining insights. They would want to use the data to find hidden information which probably they ignored earlier. Now take an example of RDBMS. What is biggest drawback in using an RDBMS? Now you might think that RDBMS is known for stability and consistency, and organizations would be interested in storing their data in Oracle or DB2 or MySQL or Microsoft SQL Server, and they have been doing that for many years now. So what has changed now? Now, when we talk about RDBMS, the first question which I would ask is, do we have access to 100% of data being online in RDBMS? The answer is no. We would only have 10 or 20 or 30% of data online, and rest of the data would be archived, which means that if an organization is interested in working on all the data, they would have to move the data from the archived storage to the processing layer, and that would involve bandwidth consumption. Now, this is one of the biggest drawbacks of RDBMS. You do not have access to 100% of data online. In many of the cases, organizations started realizing that the data which they were ignoring as being uneconomical had hidden value which they had never exploited. I had read a presentation somewhere which said, torture the data and it will confess to anything. Now that's the value of data which organizations have realized in recent past. Take an example of Facebook. Now this shows what Facebook does with its big data. And we'll come to what is big data, but let's understand a use case. Now, Facebook collects huge volumes of user data, whether that is SMS, whether that is likes, whether that is advertisements, whether that is features which people are liking, or photographs, or even user profiles. Now, by collecting this data and providing a portal which people can use to connect, Facebook is also accumulating huge volume of data. And that's way beyond petabytes. They would also be interested in analyzing this data. And one of the reasons would be they would want to personalize the experience. Take an example of personalized news feed. Depending on a user behavior, depending on what a user likes, what a user would want to know about, they can recommend a personalized news feed to every particular user. That's just one example of what Facebook does with its data. Take an example of photo tag suggestions. Now, when you log into Facebook account, you could also get suggestions on different friends whom you would like to connect to, or you would want to tag so that they could be known by others. Some more examples which show how Facebook uses its data are as follows. So the flashback, collection of photos and posts that receive the most comments and likes. Okay, there was something called as I voted that was used for 2016 elections with reminders and directions to tell users their time and place of polling. Also, something called as safety checks. In incidents such as earthquake, hurricane, or mass shooting, Facebook gives you safety checks. Now, these are some examples where Facebook is using big data. And that brings us to the question, what is big data? This was just an example where we discussed about one company which is making use of that data which has been accumulated. And it's not only for companies which are social media oriented like Facebook, where data is important. Take an example of IBM, take an example of JP Morgan Chase, take an example of GE, or any other organization which is collecting huge amount of data. They would all want to gather insights. They would want to analyze the data. They would want to be more precise in building their services or solutions which can take care of their customers. So what is big data? Big data is basically a term. It is used to describe the data that is too large and complex to store in traditional databases. And as I gave an example, it's not just about storing the data. It is also about what you can do with the data. It also means that if there is a lot of dynamism involved, can you change the underlying storage and handle any kind of data that comes in? Now, before we get into that, let's just understand what is big data. So big data is basically a term which has been given to categorize the data if it has different characteristics. Organizations would want to have the big data stored, processed, and then analyzed to get whatever useful information they can get from this data. Now, there are 5 V's of big data: volume, velocity, variety, value, veracity. Although these are 5 V's, but then there are other V's which also categorize the data as big data, such as volatility, validity, viscosity, virality of data. Okay, so these are 5 V's of big data, and if the data has one or all of these characteristics, then it can be considered as big data, including the other V's which I just mentioned. So volume basically means incredible amount of data, huge volumes of data generated every second. Now that could be used for batch processing, that could be used for real-time stream processing. Okay, you might have data being generated from different kind of devices like your cell phones, your social media websites, online transactions, wearable devices, servers, and these days with IoT we are also talking about data getting generated via Internet of Things. That is, you could have different devices which could be communicating to each other. You could be getting data from radars or lidars or even camera sensors. So there is a huge volume of data which is getting generated, and if we are talking about data which has huge volume, which is getting generated constantly or has been accumulated over a period of time, we would say that is big data. Velocity. Now this is one more important aspect of big data. Speed with which the data is getting generated. Think about stock markets, think about social media websites, think about online surveys or marketing campaigns or airline industry. So if the data is getting generated with a lot of speed, where it becomes difficult to capture, collect, process, cure, mine, or analyze the data, then we are certainly talking about big data. The next aspect of big data is variety. Now this is where we talk about structured data, semi-structured data, or unstructured data. And here I would like to ask a question. What is the difference? When do you call the data as structured, semi-structured, or unstructured? Now let's look at an example before we theoretically discuss about this. I always would like to use some examples. Let's look at a log file and let's see what is it. So if I look at this log file, and if I would say what kind of data is this, which is the highlighted one, the answer would be it is structured data. It has specific delimiters such as space. It has data which is separated by space. And if I had 100 or 1,000 or million rows which had similar kind of data, I could certainly store that in a table. I could have a predefined schema to store this data. So I would call the one which is highlighted as structured. But if I look at this portion, where I would look at a combination of this kind of data where some data has a pattern and some data doesn't. Now this is an example of semi-structured data. So if I would have a predefined structure to store this data, probably the pattern of data would break the structure. And if I look at all the data, then I would certainly call it unstructured data because there is no clear schema which can define this data. Now this is what I mean by variety of data. That is structured data which basically has a schema or has a format which could be easily understood. You have semi-structured, which could be like an XML or JSON or even your Excel sheets, where you could have some data which is structured and the other is unstructured. And when we talk about unstructured, we are talking about absence of schema. It does not have a format, it does not have a schema, and it is hard to analyze, which brings its own challenges. The next aspect is value. Now value refers to the ability to turn your data useful for business. You would have a lot of data which is being collected, as we mentioned in previous slides, right? There would be a lot of data wrangling or data pre-processing or cleaning up of data happening. And then finally, you would want to draw value from that data. But from all the data collected, what percentage of data gives us value? And if all my data can give me value, then why wouldn't I use it? This is an aspect of big data, right? Veracity. Now this means the quality of data. Billions of dollars are lost every year by organizations because the data which was collected was not of good quality, or probably they collected a lot of data and then it was erroneous. Take an example of autonomous driving projects which are happening in Europe or US, where there are car fleets which are on the road collecting data via radar sensors and camera sensors. And when this data has to be processed to train algorithms, it is realized that sometimes the data which was collected was missing in some values, might be was not appropriate or had a lot of errors. And all this process of collecting the data becomes a repetitive task because the quality of data was not good. This is just one example. We can take example from healthcare industry or stock markets or financial institutions and so on. So extracting loads of data is not useful if the data is messy or poor in quality. And that basically means that veracity is a very important V of big data. Now, apart from veracity, volume, variety, velocity, and value, we have the other V's such as viscosity, how dense the data is. Validity, is the data still valid? Volatility, is my data volatile? Or virality, is the data viral? Now, all of these different V's categorize the data as big data. Now, here we would like to talk on a big data case study, and we have taken an example of Google, which obviously is one of the companies which is churning and working on huge amount of data. Now it's actually said that if you compare one grain of sand with 1 byte of data, then Google is processing or Google is handling whole world's sand every week. That is the kind of data which Google is processing. Now in early 2000 and since then, when the number of internet users started growing, Google also faced a lot of problems in storing, increasing user data, and using the traditional servers to manage that. Now that was a challenge which Google started facing. Could they use traditional data server to store the data? Well, yes, they could, right? Storage devices have been getting cheaper day by day. But then, how much time does it take to retrieve that data? What is the seek time? What is the time taken to read and process that data? Thousands of search queries were raised per second, no doubt. Now we could say millions and billions of queries are raised per second. Every query read 100 MBs of data and consumed tens of billions of CPU cycles based on these queries. So the requirement was that they wanted to have a large, distributed, highly fault tolerant file system. Large to store, to capture, process huge amount of data. Distributed because they could not rely just on one server. Even if that had multiple disks stacked up, that was not an efficient choice. What would happen if this particular machine failed? What would happen if the whole server was down? So they needed a distributed storage and a distributed computing environment. They needed something which can be highly fault tolerant, right? So this was the requirement which Google had, and the solution which came out as a result was GFS, Google File System. Now let's look at how GFS works. So normally in any particular Linux system or Linux server, you would have a file system. You would have set of processes, you would have set of files and directories which could store the data. GFS was different. So to facilitate GFS, which could store huge amount of data, there was an architecture which had one master and multiple chunk servers, or you can say slave servers or slave machines. Master machine was to contain metadata, was to contain data about data. When we say metadata, we are talking about information about data. And then you have the chunk servers or the slave machines which could be storing data in a distributed fashion. Now any client or an API or an application which would want to read the data would first contact the master server. It would contact the machine where the master process was running, and client would place a request of reading the data or showing an interest of reading the data. Internally, what it is doing is it is requesting for metadata. Your API or an application would want to know from where it can read the data. Master server, which has metadata, whether that is in RAM or disk, we can discuss that later. But then master server would have the metadata, and it would know which are the chunk servers or the slave machines where the data was stored in a distributed fashion. Master would respond back with the metadata information to the client, and then client could use that information to read or write to these slave machines where actually the data was stored. Now this is what the process or set of processes work together to make GFS. So when you say a chunk server, we would basically have the files getting divided into fixed size chunks. Now how would they get divided? So there would be some kind of chunk size or a block size which would determine that. If the file is bigger than the pre-decided chunk size, then it would be split into smaller chunks and be distributed across the chunk servers or the slave machines. If the file was smaller, then it would still use one chunk or a block to get stored on the underlying slave machines. So these chunk servers or slave machines are the ones which actually store the data on local disks as your Linux files. Client, which is interacting with master for metadata and then interacting with chunk servers for read-write operations, would be the one which would be externally connecting to the cluster. So this is how it would look. So you have a master which would obviously be receiving some kind of heartbeats from the chunk servers to know their status and receive information in the form of packets which would let the master know which machines were available for storage, which machines already had data, and master would build up the metadata within itself. The files would be broken down into chunks. For example, we can look at file 1. It is broken down into chunk 1 and chunk 2, and file 2 has one chunk which is one portion of it, and then you have file 2 residing on some other chunk server, which also lets us know that there is some kind of auto replication for this file system, right? And the data which is getting stored in the chunk could have a data of 64 MB. Now that chunk size could be changed based on the data size, but Google File System had the basic size of the chunk as 64 MB. Each chunk would be replicated on multiple servers. The default replication was 3, and that could again be increased or decreased as per requirement. This would also mean that if a particular slave machine or a chunk server would die or would get killed or would crash, there would never be any data loss, because a replica of data residing on the failed machine would still be available on some other slave server, chunk server, or slave machine. Now this helped Google to store and process huge volumes of data in a distributed manner and thus have a fault tolerant, distributed, scalable storage which could allow them to store a huge amount of data. Now that was just one example which actually led to the solution which today we call as Hadoop. Now when we talk about big data, here I would like to ask you some questions that if we were talking about the RDBMS case, take an example of something like NASA, which was working on a project called SETI, Search of Extraterrestrial Intelligence. Now this was a project where they were looking for a solution to take care of their problem. The problem was that they would roughly send some waves in space, capture those waves back, and then analyze this data to find if there was any extraterrestrial object in space. Now they had two options for it. They could either have a huge server built which could take care of storing the data and processing it, or they could go for volunteer computing. Now volunteer computing basically means that you could have a lot of people volunteering and being part of this project, and what they would in turn do is they would be donating their RAM and storage from their machines when they are not using it. How would that happen? Basically download some kind of patch on their machine which would run as a screensaver, and if the user is not using his machine, some portion of data could be transferred to these machines for intermittent storage and processing using RAM. Now this sounds very interesting and this sounds very easy. However, it would have its own challenges, right? Think about security, think about integrity, but those problems are not bigger as much as is the requirement of bandwidth. And this is the same thing which happens in RDBMS. If you would have to move data from archived solution to the processing layer, that would consume huge amount of bandwidth. Big data brings its own challenges. Huge amount of data is getting generated every day. Now the biggest challenge is storing this huge volume of data, and especially when this data is getting generated with a lot of variety, where it can have different kind of formats, where it could be viral, it could be having a lot of value, and nobody has looked into the veracity of data. But the primary problem would be handling this huge volume of data. Variety of the data would bring in challenges of storing it in legacy systems if processing of the data was required. Now here again I would suggest you need to think what is the difference between reading a data and processing a data. So reading might just mean bringing in the data from disk and doing some IO operations, and processing would mean reading the data, probably doing some transformations on it, extracting some useful information from it, and then storing it in the same format or probably in a different format. So processing this massive volume of data is the second challenge. Organizations don't just store their big data. They would eventually want to use it, to process it, to gather some insights. Now, processing and extracting insights from big data would take huge amount of time unless and until there was an efficient solution to handle and process this big data. Securing the data, that's again a concern for organizations, right? Encryption of big data is difficult to perform. If you would think about different compression mechanisms, then that would also mean decompressing of data, which would also mean that you could take a hit on the CPU cycles or on disk usage. Providing user authentication for every team member, now that could also be dangerous.
Hello learners, Simplilearn brings you a postgraduate program in data engineering developed in partnership with Purdue University and IBM. To learn more about this course, you can find the course link in the description box below.
So that led to Hadoop as a solution. So big data brings its own challenges. Big data brings its own benefits. And here we have a solution which is Hadoop. Now what is Hadoop? It's an open source framework for storing data and running applications on clusters of commodity hardware. Hadoop is an open source framework. And before we discuss on two main components of Hadoop, it would be good to look into the link which I was suggesting earlier, that is companies using Hadoop. And any person who would be interested in learning big data should start somewhere here, where you could list down different companies, what kind of setup they have, why are they having Hadoop, what kind of processing they are doing, and how are they using these so-called Hadoop clusters to process and in fact store, capture, and process huge amount of data. Another link which I would suggest is looking at different distributions of Hadoop. Any person who is interested in learning in big data should know about different distributions of Hadoop. Now in Linux, we have different distributions like Ubuntu, CentOS, Red Hat, SUSE, Debian. In the same way, you have different distributions of Hadoop, which we can look on the wiki page. And this is the link which talks about products that include Apache Hadoop or derivative works and commercial support, which basically means that Apache Hadoop, the sole products that can be called a release of Apache Hadoop come from apache.org. That's an open source community. And then you have various vendor specific distributions like Amazon Web Services, you have Cloudera, you have Hortonworks, you have IBM's Big Insight, you have MapR. All these are different distributions of Hadoop. So basically all of these vendor specific distributions are depending or using on core Apache Hadoop. In brief, we can say that these are the vendors which take up the Apache Hadoop, package it within a cluster management solution so that users who intend to use Apache Hadoop would not have difficulties of setting up a cluster, setting up a framework. They could just use a vendor specific distribution with its cluster installation solutions, cluster management solution, and easily plan, deploy, install, and manage a cluster.
Let's rewind to the days before the world turned digital. Back then, minuscule amounts of data were generated at a relatively sluggish pace. All the data was mostly documents, and in the form of rows and columns. Storing or processing this data wasn't much trouble, as a single storage unit and processor combination would do the job. But as years passed by, the internet took the world by storm, giving rise to tons of data, generated in a multitude of forms and formats every microsecond. Semi-structured and unstructured data was available now in the form of emails, images, audio, and video, to name a few. All this data became collectively known as big data. Although fascinating, it became nearly impossible to handle this big data, and a storage unit processor combination was obviously not enough. So, what was the solution? Multiple storage units and processors were undoubtedly the need of the hour. This concept was incorporated in the framework of Hadoop that could store and process vast amounts of any data efficiently using a cluster of commodity hardware. Hadoop consisted of three components that were specifically designed to work on big data. In order to capitalize on data, The first step is storing it. The first component of Hadoop is its storage unit, the Hadoop Distributed File System, or HDFS. Storing massive data on one computer is unfeasible. Hence, data is distributed amongst many computers and stored in blocks. So, if you have 600 megabytes of data to be stored, HDFS splits the data into multiple blocks of data that are then stored on several data nodes in the cluster. 128 megabytes is the default size of each block. Hence, 600 megabytes will be split into 4 blocks, A, B, C, and D of 128 megabytes each, and the remaining 88 megabytes in the last block, E. So, now you might be wondering, what if one data node crashes? Do we lose that specific piece of data? Well, no. That's the beauty of HDFS. HDFS makes copies of the data and stores it across multiple systems. For example, when block A is created, it is replicated with a replication factor of 3 and stored on different data nodes. This is termed the replication method. By doing so, data is not lost at any cost, even if one data node crashes, making HDFS fault-tolerant. After storing the data successfully, it needs to be processed. This is where the second component of Hadoop, MapReduce, comes into play. In the traditional data processing method, entire data would be processed on a single machine having a single processor. This consumed time and was inefficient, especially when processing large volumes of a variety of data. To overcome this, MapReduce splits data into parts and processes each of them separately on different data nodes. The individual results are then aggregated to give the final output. Let's try to count the number of occurrences of words taking this example. First, the input is split into 5 separate parts based on full stops. The next step is the mapper phase, where the occurrence of each word is counted and allocated a number. After that, depending on the words, similar words are shuffled, sorted, and grouped. Following which, in the reducer phase, all the grouped words are given a count. Finally, the output is displayed by aggregating the results. All this is done by writing a simple program. Similarly, MapReduce processes each part of big data individually, and then sums the result at the end. This improves load balancing and saves a considerable amount of time. Now that we have our MapReduce job ready, it is time for us to run it on the Hadoop cluster. This is done with the help of a set of resources, such as RAM, network bandwidth, and CPU. Multiple jobs are run on Hadoop simultaneously, and each of them needs some resources to complete the task successfully. To efficiently manage these resources, we have the third component of Hadoop, which is Yarn. Yet another resource negotiator, or Yarn, consists of a resource manager, node manager, application master, and containers. The resource manager assigns resources. Node managers handle the nodes and monitor the resource usage in the node. The containers hold a collection of physical resources. Suppose we want to process the MapReduce job we had created. First, the application master requests the container from the node manager. Once the node manager gets the resources, it sends them to the resource manager. This way, Yarn processes job requests and manages cluster resources in Hadoop. In addition to these components, Hadoop also has various big data tools and frameworks dedicated to managing, processing, and analyzing data. The Hadoop ecosystem comprises several other components like Hive, Pig, Apache Spark, Flume, and Scoop, to name a few. The Hadoop ecosystem works together on big data management.
Before we dive into the technical side of Hadoop, we're going to take a little detour to try to give you a visual understanding and relate it to maybe a more life setup. And we're going to go to the farm in this case. So we have in a farm far away. I almost wish they'd put far, far away. It does remind me a little bit of a Star Wars theme. So we're going to look at fruit at a farm. We have Jack who harvests grapes and then sells it in the nearby town. After harvesting, he stores his produce in a storage shed, or a storage room in this case. We found out though is there was a high demand for other fruits, so he started harvesting apples and oranges as well. Hopefully he has a couple fields with these different fruit trees growing, and he set up there, and you can see that he's working hard to harvest all these different fruits, but he has a problem here because there's only one of him, so he can't really do more work. So what he needs to do then is hire 2 more people to work with him. With this, harvesting is done simultaneously. So instead of him trying to harvest all this different fruit, he now has 2 more people in there who are putting their fruit away and harvesting it for him. Now the storage room becomes a bottleneck to store and access all the fruits in a single storage area. So they can't fit all the fruit in one place. So Jack decides to distribute the storage area and give each one of them a separate storage. And you can look at this computer terms. We have our people that are the processors. We have our fruit that's the data, and you can see it's storing it in the different storage rooms. So you can see me popping up there getting my, hello, I want fruit basket of 3 grapes, 2 apples, and 3 oranges. I'm getting ready for a breakfast with family, a very large family. My family's not that large. To complete the order on time, all of them work parallelly with their own storage space. So here we have a process of retrieving or querying the data, and you can see from the one storage space he pulls out 3 grapes, she pulls out 2 apples, and then another storage room he pulls out 3 oranges. And we complete a nice fruit basket, and this solution helps them to complete the order on time without any hassle. All of them are happy. They're prepared for an increase in demand in the future. So they now have this growth system where you can just keep hiring on new people. They can continue to grow and develop a very large farm. So how does this story relate to big data? And I hinted at that a little bit. Earlier, the limited data, only one processor, one storage unit was needed. I remember back in the 90s, they would just upgrade the computer. Instead of having a small computer, you would then spend money for a huge mainframe with all the flashing lights on it. Then the Cray computers were really massive. Nowadays, a lot of the computers that sits on our desktop are powerful as the mainframes they had back then. So it's pretty amazing how time has changed. But you used to be able to do everything on one computer, and you had structured data and a database you stored your structured data in. So most of the time you were querying databases, SQL queries. Just think of it as a giant spreadsheet with rows and columns where everything has a very specific size and fits neatly in that rows and columns. And back in the 90s, this was a nice setup. You just upgraded your computer. You would get yourself a nice big Sun computer or a mainframe if you had a lot of data and a lot of stuff going on, and it was very easy to do. Soon, though, the data generation increased, leading to high volume of data along with different data formats. And so you can imagine, in today's world, this year we will generate more data than all the previous years summed together. We will generate more data just this year than all the previous years summed together. And that's the way it's been going for some time. And you can see we have a variety of data. We have our structured data, which is what you'd think about a database with rows and columns and easy to look at, nice spreadsheet. We have our semi-structured data. They have emails as an example here. That would be one example, your XML, your HTML, web pages. And we have unstructured data. If you ever look through your folder on photos, I have photos that were taken on my phone with high quality. I've got photos from a long time ago. I got web photos, low quality. So just in my pictures alone, none of them are the same. You know, there certainly are groups of them that are, but overall there are a lot of variety in size and setup. So a single processor was not enough to process such high volume of different kinds of data, as it was very time consuming. You can imagine that if you are Twitter with millions of Twitter feeds, you're not going to be able to do a query across one server. There's just no way that's going to happen unless people don't mind waiting a year to get the history of their tweets or look something up. Hence, we start doing multiple processors. So they're used to process high volume of data, and this saved time. So we're moving forward. We got multiple processors. The single storage unit became the bottleneck, due to which network overhead was generated. So now you have your network coming in, and each one of these servers has to wait before it can grab the data from the single stored unit. Maybe you have a SQL server there with a nice setup or a file system going. The solution was to use distributed storage for each processor. This enabled easy access to storage and access to data. So this makes a lot of sense. You have multiple workers, multiple storage units, just like we had our storage room and the different fruit coming in, your variety. You can see that nice parallel to working on a farm. Now we're dealing with a lot of data. It's all about the data now. This method worked, and there were no network overhead generated. You're not getting a bottleneck somewhere where people are just waiting for data being pulled or being processed. This is known as parallel processing with distributed storage. So parallel processing, distributed storage. And you can see here the parallel processing is your different computers running their processes, and distributed storage.
Here is a quick demo on setting up Cloudera Quick Start VM in case you are interested in working on a standalone cluster. You can download the Cloudera Quick Start VM. So you can just type in download Cloudera Quick Start VM and you can search for package. Now this can be used to set up a quick start VM, which would be a single node Cloudera based cluster. So you can click on this link and then basically based on the platform which you would be choosing to install, such as using a VM box or which version of Cloudera you would install. So here I can select a platform, so I can choose VirtualBox and then you can click on get it now. So give your details and basically then it should allow you to download the quick start VM, which would look something like this. And once you have the zip file which is downloaded, you can unzip it, which can then be used to set up a single node Cloudera cluster. So once you have downloaded the zip file, that would look something like this. So you would have a quick start VirtualBox and then a VirtualBox disk. Now this can be used to set up a cluster. Ignore these files which are related to Amazon machines and you don't need to have that. So you would just have this, and this can be used to set up a Cloudera cluster. So for this to be set up, you can click on File, Import Appliance, and here you can choose your Quick Start VM by looking into Downloads, Quick Start VM, select this and click on Open. Now you can click on Next and that shows you the specifications of CPU, RAM, which we can then change later, and click on Import. This will start importing virtual disk image .vmdk file into your VM box. Once this is done, we will have to change the specifications of our machines to use 2 CPU cores minimum and give a little more RAM, because Cloudera Quick Start VM is very CPU intensive and it needs good amount of RAM. So to survive, I will give 2 CPU cores and 5 GB RAM, and that should be enough for us to bring up a quick start VM, which gives us a Cloudera distribution of Hadoop in a single node cluster setup, which can be used for working, learning about different distributions in Cloudera cluster, working with Is Hdfs and other Hadoop ecosystem components. Let's just wait for this importing to finish and then we will go ahead and set up a quick start VM for our practice. Here the importing of appliance is done and we see Cloudera quick start machine is added to my list of machines. I can click on this and click on settings. As mentioned, I would like to give it more RAM and more CPU cores. So click on system and here let's increase the RAM to at least 5 and click on processor and let's give it 2 CPU cores, which would at least be better than using 1 CPU core. Network, it goes for NAT and that's fine. Click on OK and we would want to start this machine so that it uses 2 CPU cores, 5 GB RAM, and it should bring up my Cloudera Quick Start VM. Now let's go ahead and start this machine, which has our Quick Start VM. It might take initially some time to start up because internally there will be various Cloudera services which will be starting up, and those services need to be up for our Cloudera Quick Start VM to be accessible. So unlike your Apache Hadoop cluster, where we start our cluster and we will be starting all our processes, in case of Cloudera, it is your Cloudera SCM server and agents which take care of starting up of your services and starting up of your different roles for those services. I explained in my previous session that for a Cloudera cluster, it would be these services. Let me just show you that. So in case of Apache cluster, we start our services, that is we start our cluster by running script, and then basically those scripts will individually start the different processes on different nodes. In case of Cloudera, we would always have a Cloudera SCM server which would be running on one machine, and then including that machine we would have Cloudera SCM agents which would be running on multiple machines. Similarly, if we had a Hortonworks cluster, we would have Ambari server starting up on the first machine and then Ambari agents running on other machines. So your server component knows what are the services which are set up, what are their configurations, and agents running on every node are responsible to send heartbeats to the server, receive instructions, and then take care of starting and stopping up of individual roles on different machines. In case of our single node cluster setup in Quick Start VM, we would just have one SCM server and one SCM agent which will start on the machine, which will then take care of all the roles which need to be started for your different services. So we will just wait for our machine to come up and basically have Cloudera SCM server and agent running. And once we have that, we need to follow few steps so that we can have the Cloudera admin console accessible, which allows you to browse the cluster, look at different services, look at the roles for different services, and also work with your cluster either using command line or using the web interface, that is Hue. Now that my machine has come up and it already is connected to the internet, which we can see here, we need to do certain things so that we can have our admin console accessible. At this point of time, you can click on terminal and check if you have access to the cluster. So here type in host name and that shows you your host name, which is quickstart.cloudera. We can also type in hdfs command to see if we have access and if my cluster is working. These commands are same as you would give them in a Apache Hadoop cluster or in any other distribution of Hadoop. Sometimes when your cluster is up and you have access to the terminal, it might take few seconds or few minutes before there is a connection established between Cloudera SCM server and Cloudera SCM agent running in the background, which takes care of your cluster. I have given a DFS list command, which basically should show me what by default exists on my SDFS. Let's just give it a couple of seconds before it shows us the output. We can also check by giving a service Cloudera SCM server status, and here it tells me that if you would want to use Cloudera Express free, run this command. It needs 8 GB of RAM and at least 2 virtual CPU cores. And it also mentions it may take several minutes before Cloudera Manager has started. I can log in as root here and then give the command service Cloudera SCM server status. Remember, the password for root is Cloudera. So it basically says that if you would want to check these settings, it is good to have Express Edition running. So we can close this. My SDFS access is working fine. Let's close the terminal, and here we have launch Cloudera Express. Click on this and that will give you that you need to give a command, which is force. Let's copy this command. Let's open a different terminal and let's give this command like this, which will then go ahead and shut down your Cloudera based services, and then it will restart it, only after which you will be able to access your admin console. So let's just give it a couple of minutes before it does this, and then we will have access to our admin console. Here if you see, it is starting the Cloudera Manager server again. It is waiting for Cloudera Manager API, then starting the Cloudera Manager agents, and then configuring the deployment as per the new settings which we have given as to use the Express edition of Cloudera. Once all this is done, it will say the cluster has been restarted and the admin console can be accessed by ID and password as Cloudera. We'll give it a couple of more minutes, and once this is done, we are ready to use our admin console. Now that deployment has been configured, client configurations have also been deployed, and it has restarted the Cloudera management service, it gives you an access to quick start admin console using username and password as Cloudera. Let's try accessing it. So we can open up the browser here and let's change this to 7180. That's the default port, and that shows the admin console which is coming up. Now here we can log in as Cloudera, and then Let's click on login. Now, as I said, Cloudera is very CPU intensive and memory intensive, so it would slow down since we have not given enough GB RAM to our Cloudera cluster, and thus it will be advisable to stop or even remove the services which we don't need. Now, as of now, if we look at the services, all of them look in a stop status, and that's good in one way because we can then go ahead and remove the services which we will not use in the beginning, and later we can anytime add services to the cluster. So for example, I can click on key value store here, and then I can scroll down where it says delete to remove this service from the admin console. Now, anytime you are removing a particular service, it will only remove the service from the management by Cloudera Manager. All the role groups under this service will be removed from host templates. So we can click on delete. Now, if this service was depending on some other service, it would have prompted me with a message that remove the relevant services on which this particular service depends. If the service was already running, then it would have given me a message that the service has to be stopped before it can be deleted from the Cloudera admin console. Now, this is my admin console, which allows you to click on services, look at the different roles and processes which are running for this service. We anyways have access to our Cloudera cluster from the terminal using our regular Is Hdfs or yarn or mapret commands. Now I removed a service. I will also remove Solar, which we will not be using for the beginning, but then it depends on your choice. So we can here scroll down to delete it, and that says that before deleting the Solar service, you must remove the dependencies on this service from the configuration of following services, that is Hue. Now Hue is a web interface which allows you to work with your Is-Hdfs, and that is depending on this. So click on configure service dependency, and here we can make sure that our Hue service does not depend on a particular service we are removing, so that then we can have a clean removal of the service. So I'll click on none and I will say save changes. Once this is done, then we can go ahead and try removing the Solar service from our admin console, which will reduce some load on my management console, which will also allow me to work faster on my cluster. Now here we have removed the dependency of Hue on Solar, so we can click on this and then we can delete it. Remember, I'm only doing this so that my cluster becomes a little lighter and I can work on my focus services. At any point of time, if you want to add more services to your cluster, you can anytime do that. You can fix different configuration issues like what we see here with different warning messages. And here we have these services which are already existing. Now, if we don't need any of the service, I can click on the drop down and click on delete. Again, this says that Scoop 2 also has relevance to Hue. So Hue as a web interface also depends on Scoop 2. As of now, we'll make it none. At any point of time later, you can add the services by clicking the add service option. Now this is a cluster to which you have admin access, and this is a quick start VM which gives you a single node Cloudera cluster which you can use for learning and practicing. So here we'll click on Scoop 2 and then we will say delete, as we have configured the dependency now, and we will remove Scoop 2 also from the list of services which your admin console is managing, right? So once this is done, we have removed 3 services which we did not need. We can even remove Scoop as a client, and if we need, we can add that later. Now there are various other alerts which your Cloudera admin console shows, and we can always fix them by clicking on the health issues or configuration issues. We can click here and see what is the health issue it is pointing to, if that is a critical one or if that can be ignored. So it says there is an issue with a clock offset, which basically relates to an NTP service, network time protocol, which makes sure that one or multiple machines are in the same time zone and are in sync. So for now, we can click on suppress and we can just say suppress for all hosts, and we can say look into it later and confirm. So now we will not have that health issue reported, that probably the NTP service and the machines might not be in sync. Now that does not have an impact for our use case as of now, but if we have a Kerberos kind of setup which is for security, then basically this offset and time zone becomes important. So we can ignore this message and we are still good to use the cluster. We also have other configuration issues, and you can click on this, which might talk about the heap size or the RAM which is available for machines. It talks about Zookeeper should be in odd numbers. Hue does not have a load balancer. SDFS only has one data node. But all of these issues are not to be worried upon because this is a single node cluster setup. So if you want to avoid all of these warnings, you can always click on suppress and you can avoid and let your cluster be in all green status. But that's nothing to worry. So we can click on cluster and basically we can look at the services. So we have removed some services which we don't intend to use now. I have also suppressed a offset warning, which is not very critical for my use case. And basically I'm good to start the cluster. At any point of time, as I said, if you would want to add services, this is the actions button which you can use to add service. So we will just say restart my cluster, which will restart all the services one by one, starting from Zookeeper as the first service to come up. We can always click on this arrow mark and see what is happening in the services, what services are coming up and in which order. If you have any issues, you can always click on the link next to it, which will take you to the logs, and we can click on close to let it happen in the background. So this will basically let my services restart one by one, and my cluster will then become completely accessible either using Hue as a web interface or quick start terminal, which allows you to give your commands. Now while my machines are coming up, you can click on hosts and you can have a look at all the hosts we have. As of now only one, which will also tell you how many roles or processes are running on this machine. So that is 25 roles. It tells you what is the disk usage. It tells you what is the physical memory being used. And using this host tab, we can add new hosts to the cluster. We can check the configuration. We can check all the hosts. In diagnostics, you can look at the logs, which will give you access to all the logs. You can even select the sources from which you would want to have the logs, or you can give the host name. You can click on search. You can build your own charts. You can also do the admin stuff by adding different users or enabling security using the administration tab. So since we have clicked on restart of a cluster, we will slowly start seeing all the services one by one coming up, starting with Zookeeper to begin with. And once we have our cluster up and running, whether that is showing all services in green or in a different status, we still should be able to access the service. Now, as we saw in Apache Hadoop cluster, even here we can click on SDFS and we can access the web UI once our SDFS service is up by clicking on quick links. So the service is not yet up. Once it is up, we should be able to see the web UI link, which will allow you to check things from SDFS web interface. Similarly, Yarn as a service also has a web interface. So as soon as the service comes up, under your quick links, we will have access to the Yarn UI. And similarly, once the service comes up, we will have access to Hue, which will give you the web interface, which allows you to work with your SDFS, which allows you to work with your different other components within the cluster without even using the command line tools or command line options. So we will have to give it some time while the Cloudera SCM agent on every machine will be able to restart the roles which are responsible for your cluster to come up. We can always click here, which tells that there are some running commands in the background which are trying to start my cluster. We can go to the terminal and we can switch as SDFS user. Remember, SDFS user is the admin user and it does not have a password unless you have set one. So you can just log in as SDFS, which might ask you for a password initially, which we do not have. So the best way to do this is by logging in as root, where the password is Cloudera, and then you can log in as HDFS, so that then onwards you can give your SDFS commands to work with your file system. Now, since my services are coming up right now, when I try to give a DFS command, it might not work, or it might also say that it is trying to connect to the name node, which is not up yet. So we will have to give it some time, and only once the name node is up, we will be able to access our SDFS using commands. So this is how you can quickly set up your quick start, and then you can be working using the command line options from the terminal, like what you would do in an Apache Hadoop cluster. You could use the web interfaces which allow you to work with your cluster. Now this usually takes more time, so you will have to give it some time before your services are up and running. And for any reason, if you have issues, it might require you to restart your cluster several times in the beginning before it gets accustomed to the settings what you have given and it starts up the services. At any point of time, if you have any error message, then you can always go back and look in logs and see what is happening and try starting your cluster. So this is how we set up a quick start VM, and you can be using this to work with your Cloudera cluster.
We'll start with the big data challenges. And the first thing with the big data is you can see here we have a nice chaotic image with all these different inputs, server racks all over the place, graphs being generated, just about everything you can imagine. And so the problems that come up with big data is, one, storing it. How do you store this massive amount of data? And we're not talking about a terabyte or 10 terabytes. We're talking a minimal of 10 terabytes up to petabytes of data. And then the next question is processing. And so the two go hand in hand, because when you're storing the data, that might take up a huge amount of space. Or you might have a small amount of data that takes a lot of processing. And so either one will drive a series of data or processing into the big data arena. So with storing big data was a problem due to its massive volume, just straight up. People would have huge backup tapes, and then you'd have to go through the backup tapes for hours to go find your data, and a simple query could take days. And then processing big data consumed more time, and so the Hadoop came up with a cheap way to process the data. It used to be like, I've had some processes that if I ran on my computer without trying to use multiple cores and multiple threads would take years to process. Just a simple data analysis can get that heavy in the data processing. And so processing can be as big of a problem as the size of the data itself. So Hadoop as a solution. This is the solution to big data and big data storage. Storing big data was a problem due to its massive volume. So we take the Hadoop file system, or the HDFS, and now we're able to store huge data across a large number of machines and access it like it's one file system. And processing big data consumed more time. We talked about some processes you can't even do on your computer because it would take years. Now the Hadoop with the map reduce, processing big data was faster. And I'm going to add a little notation right here that's really important to note that Hadoop is the beginning. When we talk about data processing, they've added new processes on top of the map reduce that even accelerate it. Your Spark setup and some other different functionalities. But really the basis of all of it, where it all starts with the most basic concept, is your Hadoop map reduce. Let us now look into the HDFS in detail. In the traditional approach, all the data was stored in a single central database. With the rise of big data, a single database was not enough for storage. And I remember the old Sun computers or the huge IBM machines with all the flashing lights. Now all the data on one of those can be stored on your phone. It's almost a bit of humor how much this has accelerated over the years. The same thing with our rise of big data. No longer can you just store it on one machine. No longer can you go out and buy a Sun computer and put it on that one Sun computer. No more can you buy a Craig machine or an enterprise IBM server. It's not going to work. You're not going to fit it all into one server. The solution was to use distributed approach to store the massive amount of data. Data was divided and distributed amongst many individual databases. And you can see here where we have 3 different databases going on. So you might actually saw this in one where they divided up the user accounts A through G, so on, by the letter. And so the first query would say, what's the first letter of this, whatever ID it was, and then it would go into that database to find it. So it had a database telling it which database to look for stuff. That was a long time ago, and to be honest, it didn't work really well. Nowadays, so that was a distributed database. You'd have to track which database you put it in.
Hello learners, Simplilearn brings you a postgraduate program in data engineering developed in partnership with Purdue University and IBM. To learn more about this course, you can find the course link in the description box below.
What is HDFS? Hadoop Distributed File System, HDFS, is a specially designed file system for storing huge data sets in commodity hardware. And commodity is an interesting term because I mentioned enterprise versus commodity. And I'll touch back upon that. It has 2 core components, name node and data node. Name node is the master daemon. There's only one active name node. It manages the data nodes and stores all the metadata. So it stores all the mapping of where the data data is on your Hadoop file system. Now, the name node is usually an enterprise machine. You spend a lot of extra money on it, so you have a very solid name node machine. And so then we have our data nodes. Our data node, we have 3 here. The data node is the slave. There can be multiple data nodes, and it stores the actual data. And this is where your commodity hardware comes in. The best definition I've heard of commodity hardware is the cheap knockoffs. This is where you can buy 10 of these and you expect one of them not to work because, when they come in, they're going to break right away. So you're looking at hardware that's not as high end. So where you might have your main master node as your enterprise server, then your data nodes are just as cheap as you can get them with all the different features you need on them. As said earlier, name node stores the metadata. Metadata gives information regarding the file location, block size, and so on. So our metadata in the HDFS is maintained by using 2 files. It has the edit log and the FS image. The edit log keeps track of the recent changes made on the Hadoop file system. Only recent changes are tracked here. The FS image keeps track of every change made on the HDFS since the beginning. Now, what happens when the edit log file size increases? The name node fails. These are big ones. So what happens? We get our edit log, it just keeps so big until it's too big. Or our main enterprise computer that we spent all that money on so it wouldn't break actually fails because they still fail. The solution, we make copies of the edit log and the FS image files. So that's pretty straightforward. You just copy them over so you have both the most recent edits going on and the long-term image of your file system. And then we also create a secondary name node. It's a node that maintains the copies of the edit log and the FS image. It combines them both to get an updated version of the FS image. Now, the secondary name node only came in the last, 2-3 years where it became as part of the main system. And usually your secondary name node is also an enterprise computer. And you'll put them on separate racks. So if you have 3 racks of computers, you would have maybe the first 2 racks would have the name node and the second rack would have the secondary name node. And the reason you put them on different racks is you can have a whole rack go down. You could have somebody literally trip over the power cable, or the switch that goes between the racks is most common, goes down. Well, if the switch goes down, you can usually switch to the secondary name node. And while you're getting your switch replaced and replacing that hardware, because of the way the HDFS works, it still is completely functional. So let's take a look at the name node. We have our edit log, our FS image, and we have our secondary name node. And you take that, it copies the edit log over, and it copies the FS image. And you can see right here you have all the different contents on your main name node now also on your secondary name node. And then your secondary name node will actually take these 2, your edit log and your FS image, and it will make a copy so you have a full FS image that contains, it's current, it's up to date. The secondary name node creates a periodic checkpoint of the files, and then it updates the new FS image into the name node. Now, it used to be this all occurred on the name node before you had a secondary name node. So now you can use your secondary name node to both back up everything going on the name node, and it does that lifting in the back where you're combining your edit log and bring your FS image so it's current. And then you end up with a new edit log and you have your FS image updated and you start a fresh edit log. This process of updating happens every hour. And that's how it's scheduled. You can actually change those schedules, but that is the standard, is to update every hour.
Here we will learn on Apache Spark, history of Spark, what is Spark, Hadoop, which is a framework again, Wes Spark, components of Apache Spark, that is Spark Core, Spark SQL, Spark Streaming, Spark MLlib, and graphics. Then we will learn on Spark architecture, applications of Spark, Spark use cases. So let's begin with understanding about history of Apache Spark. It all started in 2009 as a project at UC Berkeley AMP Labs by Mate Zaheria. In 2010, it was open sourced under a BSD license. In 2013, Spark became an Apache top-level project, and in 2014, used by Databricks to sort large-scale datasets, and it set a new world record. So that's how Apache Spark started. And today, it is one of the most in-demand processing framework, or I would say in-memory computing framework, which is used across the big data industry. So what is Apache Spark? Let's learn about this. Apache Spark is an open source in-memory computing framework, or you could say data processing engine, which is used to process data in batch and also in real time across various cluster computers. And it has a very simple programming language behind the scenes, that is Scala, which is used. Although if users would want to work on Spark, they can work with Python, they can work with Scala, they can work with Java, and so on, even R for that matter. So it supports all these programming languages, and that's one of the reasons that it is called polyglot, wherein you have good set of libraries and support from all the programming languages, and developers and data scientists incorporate Spark into their applications or build Spark-based applications to process, analyze, query, and transform data at a very large scale. So these are key features of Apache Spark. Now, if you compare Hadoop with Spark, we know that Hadoop is a framework, and it basically has MapReduce, which comes with Hadoop for processing data. However, processing data using MapReduce in Hadoop is quite slow because it is a batch-oriented operation and it is time-consuming. If you talk about Spark, Spark can process the same data 100 times faster than MapReduce, as it is a in-memory computing framework. Well, there can always be conflicting ideas saying, what if my Spark application is not really efficiently coded and my MapReduce application has been very efficiently coded? Well, then it's a different case. However, normally, if you talk about code which is efficiently written for MapReduce or for Spark-based processing, Spark will win the battle by doing almost 100 times faster than MapReduce. So as I mentioned, Hadoop performs batch processing, and that is one of the paradigms of MapReduce programming model, which involves mapping and reducing, and that's quite rigid. So it performs batch processing. The intermittent data is written to Hdfs and read back from Hdfs, and that makes Hadoop's MapReduce processing slower. In case of Spark, it can perform both batch and real-time processing. However, a lot of use cases are based on real-time processing. Take an example of Macy's, take an example of retail giant such as Walmart, and there are many use cases who would prefer to do real-time processing, or I would say near real-time processing. So when we say real-time or near real-time, it is about processing the data as it comes in, or you're talking about streaming kind of data. Now, Hadoop or Hadoop's MapReduce obviously was started to be written in Java. Now you could also write it in Scala or in Python. However, if you talk about MapReduce, it will have more lines of code since it is written in Java, and it will take more times to execute. You have to manage the dependencies, you have to do the right declarations, you have to create your mapper and reducer and driver classes. However, if you compare Spark, it has few lines of code as it is implemented in Scala, and Scala is a statically typed, dynamically inferred language. It's very, very concise, and the benefit is it has features from both functional programming and object-oriented language. And in case of Scala, whatever code is written, that is converted into bytecodes, and then it runs in the JVM. Now, Hadoop supports Kerberos authentication. There are different kind of authentication mechanisms. Kerberos is one of the well-known ones, and it can really get difficult to manage. Now, Spark supports authentication via a shared secret. It can also run on Yarn, leveraging the capability of Kerberos.
Companies use big data to draw meaningful insights and take business decisions. And big data engineers are the people who can make sense out of this enormous amount of data. Now let's find out who is a big data engineer. A big data engineer is a professional who develops, maintains, tests, and evaluates the company's big data infrastructure. In other words, develop big data solutions based on a company's requirements. They maintain these solutions. They test out these solutions as to the company's requirements. They integrate this solution with the various tools and systems of the organization. And finally, they evaluate how well the solution is working to fulfill the company's requirements. Next up, let's have a look at the responsibilities of a big data engineer. Now, they need to be able to design, implement, verify, and maintain software systems. Now, for the process of ingesting data as well as processing it, they need to be able to build highly scalable as well as robust systems. They need to be able to extract data from one database, transform it, as well as load it into another data store with the process of ETL, or the extract transform load process. and they need to research as well as propose new ways to acquire data, improve the overall data quality and the efficiency of the system. Now, to ensure that all the business requirements are met, they need to build a suitable data architecture. They need to be able to integrate several programming languages and tools together so that they can generate a structured solution. They need to build models that reduce the overall complexity and increase the efficiency of the whole system by mining data from various sources. And finally, they need to work well with other teams, ones that include data architects, data analysts, and data scientists.
Now, all of you might be aware that Hadoop or Apache Hadoop is the core distribution of Hadoop. And then you have different vendors in the market which have packaged the Apache Hadoop in a cluster management solution which allows everyone to easily deploy, manage, monitor, upgrade your clusters. So here are some vendor specific distributions. We have Cloudera, which is the dominant one in the market. We have Hortonworks, and now you might be aware that Cloudera and Hortonworks have merged. So it has become a bigger entity. You have MapR, you have Microsoft Azure, IBM's InfoSphere, and Amazon Web Services. So these are some popularly known vendor specific distributions. If you would want to know more about the Hadoop distributions, you should basically look into Google and you should check for Hadoop different distributions wiki page. So if I type Hadoop different distributions and then I check for the wiki page, that will take me to the distributions and commercial support page, and this basically says that the sole products that can be called a release of Apache Hadoop come from apache.org. So that's your open source community. And then you have various vendor specific distributions which basically are running in one or the other way Apache Hadoop, but they have packaged it as a solution like an installer so that you can easily set up clusters on set of machines. So have a look at this page and read through about different distributions of Hadoop. Coming back, let's look at our next question. So what are the different Hadoop configuration files? Now, whether you're talking about Apache Hadoop, Cloudera, Hortonworks, MapR, or no matter which other distribution, these config files are the most important and existing in every distribution of Hadoop. So you have Hadoop environment.sh, wherein you will have environment variables such as your Java path, what would be your process ID path, where will your logs get stored, what kind of metrics will be collected, and so on. Your core-site file has the Hdfs path. Now this has many other properties like enabling thrash or enabling high availability or discussing or mentioning about your zookeeper. But this is one of the most important file. You have Hdfs-site file. Now this file will have other information related to your Hadoop cluster, such as your replication factor, where will name node store its metadata on disk. If a data node is running, where would data node store its data? If a secondary name node is running, where would that store a copy of name node's metadata? And so on. Your mapred-site file is a file which will have properties related to your MapReduce processing. You also have masters and slaves. Now these might be deprecated in a vendor specific distribution, and in fact you would have a yarn-site file which is based on the yarn processing framework which was introduced in Hadoop version 2, and this would have all your resource allocation and resource manager and node manager related properties. Again, if you would want to look at default properties for any one of these, for example, let's say Hdfs-site file, I could just go to Google and type in one of the properties. For example, I would say dfs.namenode.name.directory, and as I know this property belongs to Hdfs-site file, and if you search for this, it will take you to the first link which says Hdfs default XML. You can click on this and this will show you all the properties which can be given in your Hdfs-site file. It also shows you which version you are looking at, and you can always change the version here. So for example, if I would want to look at 2.6.5, I just need to change the version and that should show me the properties. Similarly, you can just give a property which belongs to say core-site file. For example, I would say fs.defaultfs, and that's a property which is in core-site file, and somewhere here you would see core minus default.xml, and this will show you all the properties. So similarly, you could search for properties which are related to yarn-site file or mapred-site file. So I could say yarn.resource manager, and I could look at one of these properties, which will directly take me to yarn default XML, and I can see all the properties which can be given in yarn. And similarly, you could say map reduce.job.reduces, and I know this property belongs to mapreduce-site file, and this takes you to the default XML. So these are important config files, and no matter which distribution of Hadoop you're working on, you should be knowing about these config files. Whether you work as a Hadoop admin or you work as a Hadoop developer, knowing these config properties would be very important, and that would also showcase your internal knowledge about the configs which drive your Hadoop cluster. Let's look at the next question. So what are the three modes in which Hadoop can run? So you can have Hadoop running in a standalone mode. Now that's your default mode. It would basically use a local file system and a single Java process. So when you say standalone mode, it is as you downloading Hadoop related package on one single machine, but you would not have any process running. That would just be to test Hadoop functionalities. You could have a pseudo distributed mode, which basically means it's a single node Hadoop deployment. Now Hadoop as a framework has many services. So it has a lot of services, and those services would be running irrespective of your distribution, and each service would then have multiple processes. So your pseudo distributed mode is a mode of cluster where you would have all the important processes belonging to one or multiple services running on a single node. If you would want to work on a pseudo distributed mode and using a Cloudera, you can always go to Google and search for Cloudera's Quick Start VM. You can download it by just saying Cloudera Quick Start VM, and you can search for this, and that will allow you to download a Quick Start VM, follow the instructions, and you can have a single node Cloudera cluster running on your virtual machines. For more information, you can refer to the YouTube tutorial where I have explained about how to set up a quick start VM. Coming back, you could have finally a production setup or a fully distributed mode, which basically means that your Hadoop framework and its components would be spread across multiple machines. So you would have multiple services such as HDFS, Yarn, Flume, Scoop, Kafka, HBase, Hive, Impala, and for these services there would be one or multiple processes distributed across multiple nodes. So this is normally what is used in production environment. So you could say standalone would be good for testing, pseudo distributed could be good for testing and development, and fully distributed would be mainly for your production setup. Now, what are the differences between regular file system and HDFS? So when you say regular file system, you could be talking about a Linux file system, or you could be talking about a Windows based operating system. So in regular file system, we would have data maintained in a single system. So the single system is where you have all your files and directories. So it is having low fault tolerance, right? So if the machine crashes, your data recovery would be very difficult unless and until you have a backup of that data. That also affects your processing. So if the machine crashes or if the machine fails, then your processing would be blocked. Now, the biggest challenge with regular file system is the seek time, the time taken to read the data. So you might have one single machine with huge amount of disks and huge amount of RAM. But then the time taken to read that data when all the data is stored in one machine would be very high, and that would be with least fault tolerance. If you talk about SDFS, your data is distributed. So SDFS stands for Hadoop Distributed File System. So here your data is distributed and maintained on multiple systems. So it is never one single machine. It is also supporting reliability. So whatever is stored in HDFS, say a file being stored, depending on its size, is split into blocks, and those blocks will be spread across multiple nodes. Not only that, every block which is stored on a node will have its replicas stored on other nodes. replication factor depends, but this makes HDFS more reliable. In cases of your slave nodes or data nodes crashing, you will rarely have data loss because of auto replication feature. Now, time taken to read the data is comparatively more, as you might have situations where your data is distributed across the nodes, and even if you are doing a parallel read, your data read might take more time because it needs coordination from multiple machines. However, if you are working with huge data which is getting stored, it will still be beneficial in comparison to reading from a single machine. So you should always think about its reliability through auto replication feature, its fault tolerance because of your data getting stored across multiple machines, and its capability to scale. So when you talk about HDFS, we are talking about horizontal scalability or scaling out. When you talk about regular file system, you are talking about vertical scalability, which is scaling up. Now, let's look at some specific HDFS questions. What is this? Why is HDFS fault tolerant? Now, as I just explained in previous slides, your HDFS is fault tolerant as it replicates data on different data nodes. So you have a master node and you have multiple slave nodes or data nodes where actually the data is getting stored. Now, we also have a default block size of 128 MB. That's the minimum since Hadoop version 2. So any file which is up to 128 MB would be using one logical block. And if the file size is bigger than 128 MB, then it will be split into blocks, and those blocks will be stored across multiple machines. Now, since these blocks are stored across multiple machines, it makes it more fault tolerant because even if your machines fail, you would still have a copy of your block existing on some other machine. Now, there are two aspects here. One, we talk about the first rule of replication, which basically means you will never have two identical blocks sitting on the same machine. And the second rule of replication is in terms of rack awareness. So if your machines are placed in racks, as we see in the right image, you will never have all the replicas placed on the same rack, even if they are on different machines. So it has to be fault tolerant and it has to maintain redundancy. So at least one replica will be placed on some other node on some other rack. That's how HDFS is fault tolerant. Now, here let's understand the architecture of HDFS. Now, as I mentioned earlier, you would in a Hadoop cluster, the main service is your HDFS. So for your HDFS service, you would have a name node, which is your master process running on one of the machines, and you would have data nodes, which are your slave machines getting stored across or the processes running across multiple machines. Each one of these processes has an important role to play. When you talk about HDFS, whatever data is written to HDFS, that data is split into blocks depending on its size, and the blocks are randomly distributed across nodes. With auto replication feature, these blocks are also auto replicated across multiple machines with the first condition that no two identical blocks will sit on the same machine. Now, as soon as the cluster comes up, your data nodes, which are part of the cluster and based on config files, would start sending their heartbeat to the name node. And this would be every 3 seconds. What does name node do with that? Name node will store this information in its RAM. So name node starts building a metadata in its RAM, and that metadata has information of what are the data nodes which are available in the beginning. Now, when a data writing activity starts and the blocks are distributed across data nodes every 10 seconds will also send a block report to name node. So name node is again adding up this information in its RAM or the metadata in RAM, which earlier had only data node information. Now name node will also have information about what are the files. The files are split in which blocks, the blocks are stored on which machines, and what are the file permissions. Now, while name node is maintaining this metadata in RAM, name node is also maintaining metadata in disk. Now, that is what we see in the red box, which basically has information of whatever information was written to HDFS. So to summarize, your name node has metadata in RAM and metadata in disk. Your data nodes are the machines where your blocks or data is actually getting stored. And then there is a auto replication feature which is always existing unless and until you have disabled it. And your read and write activity is a parallel activity. However, replication is a sequential activity. Now, this is what I mentioned about when you talk about name node, which is the master process hosting metadata in disk and RAM. So when we talk about disk, it basically has a edit log, which is your transaction log, and your FS image, which is your file system image. Right from the time the cluster was started, this metadata in disk was existing, and this gets appended every time read, write, or any other operations happen on HDFS. Metadata in RAM is dynamically built every time the cluster comes up, which basically means that if your cluster is coming up, name node in the initial few seconds or few minutes would be in a safe mode, which basically means it is busy registering the information from data nodes. So name node is one of the most critical processes. If name node is down and if all other processes are running, you will not be able to access the cluster. Name node's metadata in disk is very important for name node to come up and maintain the cluster. Name node's metadata in RAM is basically for all or satisfying all your client requests. Now when we look at data nodes, as I mentioned, data nodes hold the actual data blocks and they are sending these block reports every 10 seconds. So the metadata in name node's RAM is constantly getting updated, and metadata in disk is also constantly getting updated based on any kind of write activity happening on the cluster. Now data node, which is storing the block, will also help in any kind of read activity whenever a client requests. So whenever a client or an application or an API would want to read the data, it would first talk to name node. Name node would look into its metadata on RAM and confirm to the client which machines could be reached to get to that data. That's where your client would try to read the data from HDFS, which is actually getting the data from data nodes. And that's how your read write requests are satisfied. Now, what are the two types of metadata in name node server holds? As I mentioned earlier, metadata in disk, very important to remember, edit log and FS image. Metadata in RAM, which is information about your data nodes, files being split into blocks residing on data nodes, and file permissions. So I will share a very good link on this, and you can always look for more detailed information about your metadata. So you can search for HDFS metadata directories explained. Now this is from Hortonworks. However, it talks about the metadata in disk, which name node manages, and details about this. So have a look at this link if you are more interested in learning about metadata on disk. Coming back, let's look at the next question. What is the difference between federation and high availability? Now these are the features which were introduced in Hadoop version 2. Both of these features are about horizontal scalability of name node. So prior to version 2, the only possibility was that you could have one single master, which basically means that your cluster could become unavailable if name node would crash. So Hadoop version 2 introduced two new features, federation and high availability. However, high availability is a popular one. So when you talk about federation, it basically means any number of name nodes. So there is no limitation to the number of name nodes. Your name nodes are in a federated cluster, which basically means name nodes still belong to the same cluster, but they are not coordinating with each other. So whenever a write request comes in, one of the name node picks up that request and it guides that request for the blocks to be written on data nodes. But for this, your name node does not have to coordinate with other name node to find out if the block ID which was being assigned was the same one as assigned by other name node. So all of them belong to a federated cluster. They are linked via a cluster ID. So whenever an application or an API is trying to talk to cluster, it is always going via an cluster ID, and one of the name node would pick up the read activity or write activity or processing activity. So all the name nodes are sharing a pool of metadata in which Each name node will have its own dedicated pool, and we can remember that by a term called namespace or name service. So this also provides high fault tolerance. Suppose your one name node goes down, it will not affect or make your cluster unavailable. You will still have your cluster reachable because there are other name nodes running and they are available. Now when it comes to heartbeats, all your data nodes are sending their heartbeats to all the name nodes, and all the name nodes are aware of all the data nodes. When you talk about high availability, this is where you would only have two name nodes. So you would have an active and you would have a standby. Now normally in any environment you would see a high availability setup with Zookeeper. So Zookeeper is a centralized coordination service. So when you talk about your active and standby name nodes, election of a name node to be made as active and taking care of an automatic failover is done by your Zookeeper. High availability can be set up without Zookeeper, but that would mean that an admin's intervention would be required to make a name node as active from standby or also to take care of failover. Now at any point of time in high availability, a active name node would be taking care of storing the edits about whatever updates are happening on Hdfs, and it is also writing these edits to a shared location. Standby name node is the one which is constantly looking for these latest updates and applying to its metadata, which is actually a copy of whatever your active name node has. So in this way, your standby name node is always in sync with the active name node, and if for any reason active name node fails, your standby name node will take over and become the active. Remember, Zookeeper plays a very important role here. It's a centralized coordination service. One more thing to remember here is that in your high availability, secondary name node will not be allowed. So you would have an active name node and then you will have a standby name node which will be configured on a separate machine, and both of these will be having access to a shared location. Now that shared location could be NFS or it could be a quorum of journal nodes. So for more information, refer to the tutorial where I have explained about SDFS, high availability and federation. Now let's look at some logical question here. So if you have an input file of 350 MB, which is obviously bigger than 128 MB, how many input splits would be created by SDFS? And what would be the size of each input split? So for this, you need to remember that by default, the minimum block size is 128 MB. Now that's customizable. If your environment has more number of larger files written on an average, then obviously you have to go for a bigger block size. If your environment has a lot of files being written, but these files are of smaller size, you could be okay with 128 MB. Remember, in Hadoop, every entity, that is your directory on SDFS, file on SDFS, and a file having multiple blocks, each of these are considered as objects. And for each object, Hadoop's name node's RAM 150 bytes is utilized. So if your block size is very small, then you would have more number of blocks, which would directly affect the name node's RAM. If you keep a block size very high, that will reduce the number of blocks. But remember, that might affect in processing, because processing also depends on splits. More number of splits, more the parallel processing. So setting of block size has to be done with consideration about your parallelism requirement and your name node's RAM which is available. Now coming to the question, if you have a file of 350 MB, that would be split into 3 blocks, and here 2 blocks would have 128 MB data, and the third block, although the block size would still be 128, it would have only 94 MB of data. So this would be the split of this particular file. Now let's understand about rack awareness. How does rack awareness work? Or why do we even have racks? So organizations always would want to place their nodes or machines in a systematic way. There can be different approaches. You could have a rack which would have machines running only master processes, and the intention would be that this particular rack could have higher bandwidth, more cooling, dedicated power supply, top of rack switch, and so on. The second approach could be that you could have one master process running on one machine of every rack, and then you could have other slave processes running. Now, when you talk about your rack awareness, one thing to understand is that if your machines are placed within racks, and we are aware that Hadoop follows auto replication, the rule of replication in a rack aware cluster would be that you would never have all the replicas placed on the same rack. So if we look at this, if we have block A in blue color, you will never have all the 3 blue boxes in the same rack, even if they are on different nodes, because that makes it less fault tolerant. So you would have at least one copy of block which would be stored on a different rack on a different node. Now let's look at this. So basically here we are talking about replicas being placed in such a way. Now somebody could ask a question, can I have my block and its replicas spread across 3 racks? And yes, you can do that, but then in order to make it more redundant, you are increasing your bandwidth requirement. So the better approach would be 2 blocks on the same rack on different machines and 1 copy on a different rack.
Hello learners, Simplilearn brings you a postgraduate program in data engineering developed in partnership with Purdue University and IBM. To learn more about this course, you can find the course link in the description box below.
Now let's proceed. How can you restart name node and all daemons in Hadoop? So if you were working on an Apache Hadoop cluster, then you could be doing a start and stop using Hadoop daemon scripts. So there are these Hadoop daemon scripts which would be used to start and stop your Hadoop. And this is when you talk about your Apache Hadoop. So let's look at one particular file which I would like to show you more information here. And this talks about your different clusters. So let's look into this. And so let's look at the start and stop. And here I have a file. Let's look at this one. And this gives you highlights. So if you talk about Apache Hadoop, this is how the setup would be done. So you would have it download the Hadoop tar file, you would have to untar it, edit the config files, you would have to do formatting and then start your cluster. And here I have said using scripts. So this is in case of Apache Hadoop, you could be using a start all script that internally triggers start DFS and start yarn. And these scripts, start DFS, internally would run Hadoop daemon multiple times based on your configs to start your different processes. Then your start yarn would run yarn daemon script to start your processing related processes. So this is how it happens in Apache Hadoop. Now in case of Cloudera or Hortonworks, which is basically a vendor specific distribution, you would have say multiple services which would have one or multiple daemons running across the machines. Let's take an example here that you would have machine 1, machine 2 and machine 3 with your processes spread across. However, in case of Cloudera and Hortonworks, these are cluster management solutions. So you would never be involved in running a script individually to start and stop your processes. In fact, in case of Cloudera, you would have a Cloudera SCM server running on one of the machines and then Cloudera SCM agents running on every machine. If you talk about Hortonworks, you would have Ambari server and Ambari agent running. So your agents which are running on every machine are responsible to monitor the processes, send also their heartbeat to the master, that is your server, and your server is the one or a service which basically will give instructions to the agents. So in case of vendor specific distribution, your start and stop of processes is automatically taken care by these underlying services, and these services internally are still running these commands. However, only in Apache Hadoop you have to manually follow these to start and stop. Coming back, we can look into some command related questions. So which command will help you find the status of blocks and file system health? So you can always go for a file system check command. Now that can show you the files for a particular HDFS path. It can show you the blocks, and it can also give you information on status such as under replicated blocks, over replicated blocks, misreplicated blocks, default replication, and so on. So your FSCK file system check utility does not repair if there is any problem with the blocks, but it can give you information of blocks related to the files, on which machines they are stored, if they are replicated as per the replication factor, or if there is any problem with any particular replica. Now, what would happen if you store too many small files in a cluster? And this relates to the block information which I gave some time back. So remember, Hadoop is coded in Java. So here, every directory, every file and file related block is considered as an object. And for every object within your Hadoop cluster, name node's RAM gets utilized. So more number of blocks you have, more would be usage of name node's RAM. And if you're storing too many small files, it would not affect your disk. It would directly affect your name node's RAM. That's why in production clusters, admin guys or infrastructure specialists will take care that everyone who is writing data to HDFS follows a quota system so that you could be controlled in the amount of data you write plus the count of data an individual writes on HDFS. Now, how do you copy data from local system onto HDFS? So you can use a put command or a copy from local and then give in your local path, which is your source, and then your destination, which is your HDFS path. Remember, you can always do a copy from local using a -f option. That's a flag option, and that also helps you in writing the same file or a new file to HDFS. So with your -f, you have a chance of overwriting or rewriting the data which is existing on HDFS. So copy from local or -put. Both of them do the same thing, and you can also pass an argument when you're copying to control your replication or other aspects of your file. Now, when do you use DFS admin refresh nodes or RM admin refresh nodes? So as the command says, this is basically to do with refreshing the node information. So your refresh nodes is mainly used when, say, a commissioning or decommissioning of nodes is done. So when a node is added into the cluster or when a node is removed from the cluster, you are actually informing Hadoop master that this particular node would not be used for storage and would not be used for processing. Now in that case, you would be, once you are done with the process of commissioning or decommissioning, you would be giving these commands, that is refresh nodes and RM admin refresh nodes. So internally, when you talk about commissioning, decommissioning, there are include and exclude files which are updated. And these include and exclude files will have entry of machines which are being added to the cluster or machines which are being removed from the cluster. And while this is being done, the cluster is still running. So you do not have to restart your master process. However, you can just use these refresh commands to take care of your commissioning, decommissioning activities. Now, is there any way to change replication of files on HDFS after they are already written? And the answer is, of course, yes. So if you would want to set a replication factor at a cluster level, and if you have admin access, then you could edit your HDFS-site file, or you could say Hadoop-site file. And that would take care of replication factor being set at a cluster level. However, if you would want to change the replication after the data has been written, you could always use a setrep command. So setrep command is basically to change the replication after the data is written. You could also write the data with a different replication, and for that you could use a -d dfs.replication and give your replication factor when you are writing data to the cluster. So in Hadoop, you can let your data be replicated as per the property set in the config file. You could write the data with a different replication. You could change the replication after the data is written. So all these options are available. Now, who takes care of replication consistency in a Hadoop cluster? And what do you mean by under, over replicated blocks? Now, as I mentioned, your fsck command can give you information of over or under replicated blocks. Now, in a cluster, it is always and always name node which takes care of replication consistency. So for example, if you have set up a replication of 3, and since we know the first rule of replication, which basically means that you cannot have 2 replicas residing on the same node, it would mean that if your replication is 3, we would need at least 3 data nodes available. Now say for example, you had a cluster with 3 nodes and replication was set to 3. At one point of time, one of your name node crashed. And if that happens, your blocks would be under replicated. That means there was a replication factor set, but now your blocks are not replicated, or there are not enough replicas as per the replication factor set. This is not a problem. Your master process or name node will wait for some time before it will start the replication of data again. So if a data node is not responding, or if a disk has crashed, and if name node does not get information of a replica, name node will wait for some time and then it will start re-replication of those missing blocks from the available nodes. However, while name node is doing it, the blocks are in under replicated situation. Now when you talk about over replicated, this is a situation where name node realizes that there are extra copies of block. Now this might be the case that you had 3 nodes running with a replication of 3. One of the node went down due to a network failure or some other issue. Within few minutes, name node re-replicated the data, and then the failed node is back with its set of blocks. Again, name node is smart enough to understand that this is a over replication situation, and it will delete set of blocks from one of the nodes. It might be the node which has been recently added, it might be your old node which has joined your cluster again, or any node. That depends on the load on a particular node. Now we discussed about Hadoop, we discussed about SDFS. Now we will discuss about MapReduce, which is the programming model, and you can say processing framework. What is distributed cache in MapReduce? Now we know that when we talk about MapReduce, the data which has to be processed might be existing on multiple nodes. So when you would have your MapReduce program running, it would basically read the data from the underlying disks. Now this could be a costly operation if every time the data has to be read from disk. So distributed cache is a mechanism wherein data set or data which is coming from the disk can be cached and available for all worker nodes. Now how will this benefit? So when a MapReduce is running, instead of every time reading the data from disk, it would pick up the data from distributed cache, and this will benefit your MapReduce processing. So distributed cache can be set in your job conf, where you can specify that a file should be picked up from distributed cache. Now let's understand about these roles. So what is a record reader, what is a combiner, what is a partitioner, and what kind of roles do they play in a MapReduce processing paradigm or MapReduce operation. So record reader communicates with the input split, and it basically converts the data into key value pairs. And these key value pairs are the ones which will be worked upon by the mapper. Your combiner is an optional phase. It's like a mini reduce. So combiner does not have its own class. It relies on the reducer class. Basically, your combiner would receive the data from your map tasks which would have completed, works on it based on whatever reducer class mentions, and then passes its output to the reducer phase. Partitioner is basically a phase which decides how many reduce tasks would be used, aggregate or summarize your data. So partitioner is a phase which would decide based on the number of keys, based on the number of map tasks. Your partitioner would decide if one or multiple reduce tasks would be used to take care of processing. So either it could be partitioner which decides on how many reduce tasks would run, or it could be based on the properties which we have set within the cluster, which will take care of the number of reduce tasks which would be used. Always remember, your partitioner decides how outputs from combiner are sent to reducer and to how many reducers. It controls the partitioning of keys of your intermediate map outputs. So map phase, whatever output it generates is an intermediate output, and that has to be taken by your partitioner or by a combiner and then partitioner to be sent to one or multiple reduce tasks. This is one of the common questions which you might face. Why is MapReduce slower? in processing. So we know MapReduce goes for parallel processing. We know we can have multiple map tasks running on multiple nodes at the same time. We also know that multiple reduce tasks could be running. Now, why does then MapReduce become a slower approach? First of all, your MapReduce is a batch oriented operation. Now, MapReduce is very rigid and it strictly uses mapping and reducing phases. So no matter what kind of processing you would want to do, you would have to still provide the mapper function and the reducer function to work on data. Not only this, whenever your map phase completes, the output of your map phase, which is an intermittent output, would be written to Hdfs and thereafter underlying disks. And this data would then be shuffled and sorted and picked up for reducing phase. So every time your data being written to Hdfs and retrieved from Hdfs makes MapReduce a slower approach. The question is, for a MapReduce job, is it possible to change the number of mappers to be created? Now, by default, you cannot change the number of map tasks because number of map tasks depends on the input splits. However, there are different ways in which you can either set a property to have more number of map tasks which can be used, or you can customize your code or make it use a different format which can then control the number of map tasks. By default, number of map tasks are equal to the number of splits of file you are processing. So if you have a 1 GB of file that is split into 8 blocks of 128 MB, there would be 8 map tasks running on the cluster. These map tasks are basically running your mapper function. If you have hard-coded properties in your mapred-site file to specify more number of map tasks, then you could control the number of map tasks. Let's also talk about some data types. So when you prepare for Hadoop, when you want to get into big data field, you should start learning about different data formats. Now there are different data formats such as Avro, Parquet, you have sequence file or binary format, and these are different formats which are used. Now when you talk about your data types in Hadoop, these are implementation of your writable and writable comparable interfaces. So for every data type in Java, you have a equivalent in Hadoop. So int in Java would be int writable in Hadoop, float would be float writable, long would be long writable, double writable, boolean writable, array writable, map writable, and object writable. So these are your different data types that could be used within your MapReduce program. And these are implementation of writable and writable comparable interfaces. What is speculative execution? Now imagine you have a cluster which has huge number of nodes and your data is spread across multiple slave machines or multiple nodes. Now at a point of time, due to a disk degrade or network issues or machine heating up or more load being on a particular node, there can be a situation where your data node will execute task in a slower manner. Now in this case, if speculative execution is turned on, there would be a shadow task or another similar task running on some other node for the same processing. So whichever task finishes first will be accepted and the other task would be killed. So speculative execution could be good if you are working in an intensive workload kind of environment, where if a particular node is slower, you could benefit from a unoccupied or a node which has less load to take care of your processing. Going further, this is how we can understand. So node A, which might be having a slower task, you would have a scheduler which is maintaining or having knowledge of what are the resources available. So if speculative execution as a property is turned on, then the task which was running slow, a copy of that task, or you can say a shadow task, would run on some other node, and whichever task completes first will be considered. This is what happens in your speculative execution. Now, how is identity mapper different from chain mapper? Now this is where we are getting deeper into MapReduce concepts. So when you talk about mapper, identity mapper is the default mapper which is chosen when no mapper is specified in MapReduce driver class. So for every MapReduce program, you would have a map class which is taking care of your mapping phase, which basically has a mapper function and which would run one or multiple map tasks, right? Your program would also have a reduce class which would be running a reducer function which takes care of reduce tasks running on multiple nodes. Now, if a mapper is not specified within your driver class, so driver class is something which has all information about your flow. What's your map class? What is your reduce class? What's your input format? What's your output format? What are the job configurations and so on? So identity mapper is the default mapper which is chosen when no mapper class is mentioned in your driver class. It basically implements an identity function which directly writes all its key pairs into output. And it was defined in old MapReduce API in this particular package. But when you talk about chaining mappers or chain mapper, this is basically a class to run multiple mappers in a single map task. Or basically you could say multiple map tasks would run as a part of your processing. The output of first mapper would become as an input to second mapper and so on. And this can be defined in the undermentioned class or package. What are the major configuration parameters required in a MapReduce program? Obviously, we need to have the input location. We need to have the output location. So input location is where the files will be picked up from, and this would preferably on Is Hdfs directory. Output location is the path where your job output would be written by your MapReduce program. You also need to specify input and output formats. If you don't specify, the defaults are considered. Then we need to also have the classes which have your map and reduce functions. And if you intend to run the code on a cluster, you need to package your class in a jar file, export it to your cluster, and then this jar file would have your mapper, reducer, and driver classes. So these are important configuration parameters which you need to consider for a MapReduce program. Now, what is the difference, or what do you mean by map side join and reduce side join? Map side join is basically when the join is performed at the mapping level or at the mapping phase, or is performed by the mapper. So each input data which is being worked upon has to be divided into same number of partitions. Input to each map is in the form of a structured partition and is in sorted order. So map side join, you can understand it in a simpler way that if you compare it with RDBMS concepts where you had two tables which were being joined, it will always be advisable to give your bigger table as the left side table or the first table for your join condition, and it would be your smaller table on the left side and your bigger table on the right side, which basically means the smaller table could be loaded in memory and could be used for joining. So map side join is a similar kind of mechanism where input data is divided into same number of partitions. When you talk about reduce side join, here the join is performed by the reducer. So it is easier to implement than map side join, as all the sorting and shuffling will send the values or send all the values having identical keys to the same reducer. So you don't need to have your data set in a structured form. So look into your map side join or reduce side join and other joins just to understand how MapReduce works. However, I would suggest not to focus more on this because MapReduce is still being used for processing, but the amount of MapReduce based processing has decreased overall or across the industry. Now, what is the role of output committer class in a MapReduce job? So output committer, as the name says, describes the commit of task output for a MapReduce job. So we could have this as mentioned, org Apache Hadoop MapReduce output committer. You could have a class which extends your output committer class. So MapReduce relies on this. MapReduce relies on the output committer of the job to set up the job initialization, cleaning up the job after the job completion. That means all the resources which were being used by a particular job, setting up the task temporary output, checking whether a task needs a commit, committing the task output, and discarding the task out. So this is a very important class and can be used within your MapReduce job. What is the process of spilling in MapReduce? What does that mean? So spilling is basically a process of copying the data from memory buffer to disk when obviously the buffer usage reaches a certain threshold. So if there is not enough memory in your buffer, in your memory, then the content which is stored in buffer or memory has to be flushed out. So by default, a background thread starts spilling the content from memory to disk after 80% of buffer size is filled. Now when is the buffer being used? So when your MapReduce processing is happening, the data is being read from the disk, loaded into the buffer, and then some processing happens. Same thing also happens when you are writing data to the cluster. So you can imagine for a 100 megabyte size buffer, the spilling will start after the content of buffer reaches 80 megabytes. This is customizable. How can you set the mappers and reducers for a MapReduce job? So these are the properties. So number of mappers and reducers, as I mentioned earlier, can be customized. So by default, your number of map tasks depends on the split, and number of reduced tasks depends on the partitioning phase, which decides number of reduced tasks which would be used depending on the keys. However, we can set these properties either in the config files or provide them on the command line, or also make them part of our code, and this can control the number of map tasks or reduced tasks which would be run for a particular job. Let's look at one more interesting question. What happens when a node running a map task fails before sending the output to the reducer? So there was a node which was running a map task, and we know that there could be one or multiple map tasks running on one or multiple nodes, and all the map tasks have to be completed before the further stages that such as combiner or reducer come into existence. So in a case if a node crashes where a map task was assigned to it, the whole task will have to be run again on some other node. So in Hadoop version 2, Yarn framework has a temporary daemon called application master. So your application master is taking care of execution of your application. And if a particular task on a particular node failed due to unavailability of node, it is the role of application master to have this task scheduled on some other node. Now, can we write the output of MapReduce in different formats? Of course we can. So Hadoop supports various input and output formats. So you can write the output of MapReduce in different formats. So you could have the default format, that is text output format, wherein records are written as line of text. You could have sequence file, which is basically to write sequence files or your binary format files, where your output files need to be fed into another MapReduce jobs. You could go for a map file output format to write output as map files. You could go for a sequence file as a binary output format. So that's again a variant of your sequence file input format. It basically writes keys and values to a sequence file. So when we talk about binary format, we are talking about a non-human readable format. DB output format. Now this is basically used when you would want to write data to say relational databases or say NoSQL databases such as HBase. So this format also sends the reduce output to a SQL table. Now let's learn a little bit about Yarn. Yarn, which stands for yet another resource negotiator. It's the processing framework. So what benefits did Yarn bring in Hadoop version 2, and how did it solve the issues of MapReduce version 1? So MapReduce version 1 had major issues when it comes to scalability or availability because, in Hadoop version 1, you had only one master process for processing layer, and that is your job tracker. So your job tracker was listening to all the task trackers which were running on multiple machines. So your job tracker was responsible for resource tracking and job scheduling. In Yarn, you still have a processing master, but that's called resource manager instead of job tracker. And now with Hadoop version 2, you could even have resource manager running in high availability mode. You have node managers, which would be running on multiple machines, and then you have a temporary daemon called application master. So in case of Hadoop version 2, your resource manager or master is only handling the client connections and taking care of tracking the resources. The jobs scheduling, or basically taking care of execution across multiple nodes, is controlled by application master till the application completes. So in Yarn, you can have different kind of resource allocations that could be done, and there is a concept of container. So container is basically a combination of RAM and CPU cores. Yarn can run different kind of workloads. So it is not just map reduce kind of workload which can be run on Hadoop version 2, but you could have graph processing, massive parallel processing, you could have real-time processing, and huge processing applications could run on a cluster based on Yarn. So when we talk about scalability, in case of your Hadoop version 2, you can have a cluster size of more than 10,000 nodes and can run more than 100,000 concurrent tasks. And this is because for every application which is launched, you have this temporary daemon called application master. So if I would have 10 applications running, I would have 10 app masters running, taking care of execution of these applications across multiple nodes. Compatibility. So Hadoop version 2 is fully compatible with whatever was developed as per Hadoop version 1, and all your processing needs would be taken care by Yarn. So dynamic allocation of cluster resources, taking care of different workloads, allocating resources across multiple machines and using them for execution, all that is taken care by Yarn. Multi-tenancy, which basically means you could have multiple users or multiple teams. You could have open source and proprietary data access engines, and all of these could be basically hosted using the same cluster. Now, how does Yarn allocate resources to an application with the help of its architecture? So basically, you have a client or an application or an API which talks to resource manager. Resource manager is, as I mentioned, managing the resource allocation in the cluster. When you talk about resource manager, you have its internal two components. One is your scheduler and one is your applications manager. So when we say resource manager being the master is tracking the resources, resource manager is the one which is negotiating the resources with slave. It is not actually resource manager who is doing it, but these internal components. So you have a scheduler which allocates resources to various running applications. So scheduler is not bothered about tracking your resources or basically tracking your applications. So we can have different kind of schedulers such as FIFO, which is first in first out. You could have a fair scheduler or you could have a capacity scheduler. And these schedulers basically control how resources are allocated to multiple applications when they are running in parallel. So there is a queue mechanism. So scheduler will schedule resources based on requirements of application, but it is not monitoring or tracking the status of applications. Your applications manager is the one which is accepting the job submissions. It is monitoring and restarting the application masters. So it's application manager which is basically then launching a application master which is responsible for an application. So this is how it looks. So whenever a job submission happens, we already know that resource manager is aware of the resources which are available with every node manager. So on every node which has fixed amount of RAM and CPU cores, some portion of resources, that is your RAM and CPU cores, are allocated to node manager. Now resource manager is already aware of how much resources are available across nodes. So whenever a client request comes in, resource manager will make a request to node manager. It will basically request node manager to hold some resources for processing. Node manager would basically approve or disapprove this request of holding resources. And these resources, that is a combination of RAM and CPU cores, are nothing but containers. We can allocate containers of different sizes within yarn-site file. So your node manager based on a request from resource manager guarantees the container which would be available for processing. That's when your resource manager starts a temporary daemon called application master to take care of your execution. So your app master, which was launched by resource manager, or we can say internally by applications manager, will run in one of the containers, because application master is also a piece of code. So it will run in one of the containers, and then other containers will be utilized for execution. This is how Yarn is basically taking care of your allocation. Your application master is managing resource needs. It is the one which is interacting with scheduler, and if a particular node crashes, it is the responsibility of app master to go back to the master, which is resource manager, and negotiate for more resources. So your app master will never ever negotiate resources with node manager directly. It will always talk to resource manager, and resource manager is the one which negotiates the resources. Container, as I said, is a collection of resources like your RAM, CPU, network bandwidth, and your container is allocated based on the availability of resources on a particular node. So, which of the following has occupied the place of a job tracker of MapReduce? So it is your resource manager. So resource manager is the name of the master process in Hadoop version 2. Now, if we would have to write yarn commands to check the status of an application, so we could just say yarn application minus status and then the application ID. And you could kill it also from the command line. Remember, your yarn has a UI, and you can even look at your applications from the UI. You can even kill your applications from the UI. However, knowing the command line commands would be very useful. Can we have more than one resource manager in a yarn based cluster? Yes, we can. That is what Hadoop version 2 allows us to have. So you can have a high availability yarn cluster where you have an active and standby, and the coordination is taken care by your zookeeper. At a particular time, there can only be one active resource manager, and if active resource manager fails, your standby resource manager comes and becomes active. However, zookeeper is playing a very important role. Remember, zookeeper is the one which is coordinating the server state, and it is doing the election of active to standby failover. What are the different schedulers available in Yarn? So you have a FIFO scheduler, that is first in, first out. And this is not a desirable option, because in this case, a longer running application might block all other small running applications. Your capacity scheduler is basically a scheduler where dedicated queues are created and they have fixed amount of resources. So you can have multiple applications accessing the cluster at the same time, and they would be using their own queues and the resources allocated to them. If you talk about fair scheduler, you don't need to have a fixed amount of resources. You can just have a percentage, and you could decide what kind of fairness is to be followed, which basically means that if you were allocated 20 gigabytes of memory, however, the cluster has 100 gigabytes, and the other team was assigned 80 gigabytes of memory, then you have 20% access to the cluster, another team has 80%. However, if the other team does not come up or does not use the cluster, in a fair scheduler, you can go up to maximum of 100% of your cluster. To find out more information about your schedulers, you could either look in Hadoop definitive guide, or what you could do is you could just go to Google and you could type, for example, yarn scheduler. Let's search for yarn scheduler, and then you can look in Hadoop definitive guide. And so this is your Hadoop definitive guide, and it beautifully explains about your different schedulers, how do multiple applications run, and that could be in your FIFO kind of scheduling, it could be in capacity scheduler, or it could be in a fair scheduling. So have a look at this link. It's a very good link. You can also search for yarn untangling, and this is a blog of this is a series of 4 blogs where it's beautifully explained about your yarn, how it works, how the resource allocation happens, what is a container, and what runs within the container. So you can scroll down, you can be reading through this, and you can then also search for part 2 of it, which talks about allocation and so on. So coming back, we basically have these schedulers. What happens if a resource manager fails while executing an application in a high availability cluster? So in a high availability cluster, we know that we would have 2 resource managers, one being active, one being standby, and zookeeper, which is keeping a track of the server states. So if a RM fails in case of high availability, the standby will be elected as active, and then basically your resource manager or the standby would become the active one. And this one would instruct the application master to abort in the beginning. Then your resource manager recovers its running state. So there is something called as RM state store, where all the applications which are running, their status is stored. So resource manager recovers its running state by looking at your state store, by taking advantage of container statuses, and then continues to take care of your processing. Now, in a cluster of 10 data nodes, each having 16 GB and 10 cores, what would be total processing capacity of the cluster? Take a minute to think. 10 data nodes, 16 GB RAM per node, 10 cores. So, if you mention the answer as 160 GB RAM and 100 cores, then you went wrong. Now think of a cluster which has 10 data nodes, each having 16 GB RAM and 10 cores. Remember, on every node in a Hadoop cluster, you would have one or multiple processes running. Those processes would need RAM. The machine itself, which has a Linux file system, would have its own processes. So that would also be having some RAM usage, which basically means that if you talk about 10 data nodes, you should deduct at least 20 to 30% towards the overheads, towards the Cloudera based services, towards the other processes which are running. And in that case, I could say that you could have 11 or 12 GB available on every machine for processing, and say 6 or 7 cores. Multiply that by 10, and that's your processing capacity. Remember, the same thing applies to the disk usage also. So if somebody asks you, in a 10 data node cluster where each machine has 20 terabytes of disks, what is my total storage capacity available for Is Hdfs? So the answer would not be 200. You have to consider the overheads. And this is basically which gives you your processing capacity. Now let's look at one more question. So what happens if requested memory or CPU cores beyond or goes beyond the size of container? Now, as I said, you can have your configurations which can say that in a particular data node which has 100 GB RAM, I could allocate say 50 GB for the processing. Out of 100 cores, I could say 50 cores for processing. So if you have 100 GB RAM and 100 cores, you could ideally allocate 100 for processing, but that's not ideally possible. So if you have 100 GB RAM, you would go for 50 GB. And if you have 100 cores, you would go for 50 cores. Now, within this RAM and CPU cores, you have the concept of containers, right? So container is a combination of RAM and CPU cores. So you could have a minimum size container and maximum size container. Now, at any point of time, if your application starts demanding more memory or more CPU cores, and this cannot fit into a container allocation, your application will fail. Your application will fail because you requested for a memory or a combination of memory and CPU cores which is more than the maximum container size. So look into this yarn tangling website which I mentioned, and look for the second blog in those series which explains about these allocations. Now here we will discuss on Hive, Pig, HBase, and these components of Hadoop which are being used in the industry for various use cases. Let's look at some questions here and let's look how you should prepare for them. So first of all, we will learn on Hive, which is a data warehousing package. So the question is, what are the different components of a Hive architecture? Now, when we talk about Hive, we already know that Hive is a data warehousing package, which basically allows you to work on structured data or data which can be structurized. So normally people are well versed with querying or basically processing the data using SQL queries. A lot of people come from database backgrounds and they would find it comfortable if they know structured query language. Hive is one of the data warehousing package which resides within a Hadoop ecosystem. It uses Hadoop's distributed file system to store the data, and it uses RDBMS usually to store the metadata, although metadata can be stored locally also. So what are the different components of an Hive architecture? So it has a user interface. So user interface calls the execute interface to the driver. This creates a session to the query, and then it sends the query to the compiler to generate an execution plan for it. Usually, whenever Hive is set up, it would have its metadata stored in an RDBMS. Now, to establish the connection between RDBMS and Hadoop, we need ODBC or JDBC connector jar file, and that connector jar file has a driver class. Now this driver class is mandatory to create a connection between Hive and Hadoop. So user interface creates this interface using the driver. Now we have Metastore. Metastore stores the metadata information. So any object which you create, such as database, table, indexes, their metadata is stored in Metastore, and usually this Metastore is stored in an RDBMS so that multiple users can connect to Hive. So your Metastore stores the metadata information and sends that to the compiler for execution of a query. What does the compiler do? It generates the execution plan. It has a DAG. Now DAG stands for direct acyclic graph. So it has a DAG of stages where each stage is either a metadata operation, a map or reduce job, or an operation on Hdfs. And finally, we have execution engine that acts as a bridge between Hive and Hadoop to process the query. So execution engine communicates bidirectionally with Metastore to perform operations like create or drop tables. So these are four important components of Hive architecture. Now, what is the difference between external table and managed table in Hive? So we have various kinds of table in Hive, such as external table, managed table, partition table. The major difference between your managed and external table is in respect to what happens to the data if the table is dropped. Usually, whenever we create a table in Hive, it creates a managed table, or we could also call that as an internal table. Now this manages the data and moves it into warehouse directory by default. Whether you create a managed table or external table, usually the data can reside in Hive's default warehouse directory, or it could be residing in a location chosen. However, when we talk about managed table, if one drops a managed table, not only the metadata information is deleted, but the table's data is also deleted from Hdfs. If we talk about external table, it is created with an external keyword explicitly, and if an external table is dropped, nothing happens to the data which resides in Hdfs. So that's the main difference between your managed and external table. What might be the use case if somebody asks you? There might be a migration kind of activity, or you are interested in creating a lot of tables using your queries. So in that case, you could dump all the data on Hdfs, and then you could create a table by pointing to a particular directory or multiple directories. Now you could then do some testing of your tables and would decide that you might not need all the tables. So in that case, it would be advisable to create external tables so that even if the table is later dropped, the data on Hdfs will be intact, unlike your managed table where dropping of table will delete the data from Hdfs also. Let's learn a little bit on partition. So what is partition in Hive and why is partitioning required in Hive? If somebody asks you that. Now, normally in world of RDBMS, partition is the process to group similar type of data together. And that is usually done on basis of a column or what we call as partitioning key. Now, each table usually has one column in context of RDBMS, which could be used to partition the data. And why do we do that? So that we can avoid scanning the complete table for a query and restrict the scan to set of data or to a particular partition. In Hive, we can have any number of partition keys. So partitioning provides granularity in Hive table. It reduces the query latency by scanning only relevant partition data instead of whole data set. We can partition at various levels. Now, if I compare RDBMS with Hive, in case of RDBMS, you could have one column which could be used for partitioning, and then you could be querying the specific partition. So in case of RDBMS, your partition column is usually a part of the table definition. So for example, if I have an employee table, I might have employee ID, employee name, employee age, and employee salary as 4 columns, and I would decide to partition the table based on salary column. Now, why would I partition it? Because I feel that employee table is growing very fast. It will have huge amount of data, and later when we query the table, we don't want to scan the complete table. So I could split my data into multiple partition based on a salary column giving some ranges. In Hive, it is a little different. In Hive, you can do partitioning, and there is a concept of static and dynamic partitioning. But in Hive, the partition column is not part of table definition. So you might have an employee table with employee ID, name, age, and that's it. That would be the table definition. But you could then have partitioning done based on salary column, which will then create a specific folder on Hdfs. In that case, when we query the data, we can see the partition column also showing up. So we can partition the transaction data for a bank, for example, based on month like Jan, Feb, etc. And any operation regarding a particular month will then allow us to query that particular folder. That is where partitioning is useful. Now, why does Hive not store metadata information in Hdfs if somebody asks you? So we know that Hive's data is stored in Hdfs, which is Hadoop distributed file system. However, the metadata is either stored locally, and that mode of Hive would be called as embedded mode, or you could have Hive's metadata stored in RDBMS so that multiple clients can initiate a connection. Now this metadata, which is very important for Hive, would not be stored in Hdfs. So we already know that Hdfs read and write operations are time consuming. It is a distributed file system and it can accommodate huge amount of data. So Hive stores metadata information in metastore using RDBMS instead of Hdfs. So this allows to achieve low latency and faster data access. Now, if somebody asks, what are the components used in Hive query processor? So usually we have the main components are your parser, your execution engine, logical plan generation, optimizer, and type checking. So whenever a query is submitted, it will go through a parser, and parser would check the syntax, it would check for objects which are being queried and other things to see if the query is fine. Now internally you have a semantic analyzer which will also look at the query. You have an execution engine which basically will work on the execution part. That is the best generated execution plan which could be used to get the results for the query. You could also have user-defined functions which a user would want to use, and these are normally created in Java or Java programming language, and then basically these user-defined functions are added to the class path. Now you would have a logical plan generation which basically looks at your query and then generates a logical plan or the best execution path which would be required to get to the results. Internally, there is a physical plan generated, which is then looked in by optimizer to get the best path to get to the data. And that might also be checking your different operators which you are using within your query. Finally, we would also have type checking. So these are important components in Hive. So somebody might ask you, if you are querying your data using Hive, what are the different components involved? Or if you could explain what are the different components which work when a query is submitted. So these are the components. Now let's look a scenario-based question. Suppose there are a lot of small CSV files which are present in a Hdfs directory, and you want to create a single Hive table from these files. So data in these files have fields like registration number, name, email, address. So if This is what needs to be done. What will be your approach to solve it? Where will you create a single Hive table for lots of small files without degrading the performance of the system? So there can be different approaches. Now we know that there are a lot of small CSV files which are present in a directory. So we know that when we create a table in Hive, we can use a location parameter. So I could say create table, give a table name, give the column and their data types. I could specify the delimiters, and finally I could say location and then point it to a directory on HDFS. And this directory might be the directory which has a lot of CSV files. So in this case, I will avoid loading the data in the table, because table pointing to the directory will directly pick up the data from one or multiple files. And we also know that Hive does schema check on read. So it does not do a schema check on write. So in case there were one or two files which did not follow the schema of the table, it would not prevent data loading. Data would anyways be loaded. Only when you query the data, it might show you null values if data which was loaded does not follow the schema of the table. This is one approach. What is the other approach? So let's look at that. You can think about sequence file format, which is basically a smart format or a binary format, and you can group these small files together to form a sequence file. Now this could be one other smarter approach. So we could create a temporary table. So we could say create table, give a table name, give the column names and their data types. We could specify the delimiters as it shows here, that is row format, and fields terminated by. And finally, we can store that as text file. Then we can load data into this table by giving a local file system path. And then we can create a table that will store data in sequence file format. So my point 1 is storing the data in text file. Point 3 would be storing the data in sequence file format. So we say create table, give the specifications. We say row format delimited, fields are terminated by, comma, stored as sequence file. Then we can move the data from test table into test sequence file table. So I could just say insert overwrite my new table as select star from other table. Remember, in Hive, you cannot do insert, update, delete. However, if the table is existing, you can do a insert overwrite from an existing table into a new table. So this could be one approach where we could have a lot of CSV files or smaller files clubbed together as one big sequence file and then store it in the table. Now, if somebody asks you, write a query to insert a new column, that is integer data type, into a Hive table, and the requirement might be that you would want to insert this table at a position before an existing column. Now that's possible by doing an alter table, giving your table name, and then specifying change column, giving your new column with the data type before an existing column. This is a simple way wherein you can insert a new column into a Hive table. What are the key differences between Hive and Pig? Now, some of you might have heard Hive is a data warehousing package and Pig is more of a scripting language. Both of them are used for data analysis, trend detection, hypothesis testing, data transformation, and many other use cases. So if we compare Hive and Pig, Hive uses a declarative language called HiveQL, that is Hive querying language, similar to SQL, and it is for reporting or for data analysis, even for data transformation or for your data extraction. Pig uses a high-level procedural language called Pig Latin for programming. Both of them, remember, use MapReduce processing framework. So when we run a query in Hive to process the data, or when we create and submit a Pig script, both of them trigger a MapReduce job unless and until we have set them to local mode. Hive operates on the server side of the cluster and basically works on structured data or data which can be structurized. Pig usually works or operates on the client side of the cluster and allows both structured, unstructured, or even I could say semi-structured data. Hive does not support Avro file format by default. However, that can be done by using the write serializer deserializer. So we can have Hive table related data stored in Avro format, in sequence file format, in Parquet format, or even as a text file format. However, when we are working on smarter formats like Avro or sequence file or Parquet, we might have to use specific serializers, deserializers. For Avro, this is the package which allows us to use Avro format. Pig supports Avro format by default. Hive was developed by Facebook and it supports partitioning, and Pig was developed by Yahoo and it does not support partitioning. So these are high level differences. There are lots and lots of differences. Remember, Hive is more of a data warehousing package and Pig is more of a scripting language or a strictly procedural flow following scripting language which allows us to process the data. Now let's get more deeper and learn about Pig, which is, as I mentioned, a scripting language which can be used for your data processing. It also uses MapReduce, although we can even have Pig run in a local mode. Let's learn about Pig in the next section. Now let's learn on some questions about Pig, which is a scripting language and it is extensively used for data processing and data analysis. So the question is, how is Apache Pig different from MapReduce? Now we all know that MapReduce is a programming model. It's quite rigid when it comes to processing the data because you have to do the mapping and reducing. You have to write huge code. Usually MapReduce is written in Java, but now it can also be written in Python. It can be written in Scala and other programming languages. So if we compare Pig with MapReduce, Pig obviously is very concise. It has less lines of code when compared to MapReduce. Now, we also know that Pig script internally will trigger a MapReduce job. However, user need not know about MapReduce programming model. They can simply write simple scripts in Pig and that will automatically be converted into MapReduce. However, MapReduce has more lines of code. Pig is high-level language which can easily perform join operations or other data processing operations. MapReduce is a low-level language which cannot perform join operations easily. So we can do join using MapReduce. However, it's not really easy in comparison to Pig. Now, as I said, on execution, every Pig operator is converted internally into a MapReduce job. So every Pig script which is run, which would be converted into MapReduce job. Now MapReduce overall is a batch oriented processing, so it takes more time to compile, it takes more time to execute, either when you run a MapReduce job or when it is triggered by Pig script. Pig works with all versions of Hadoop, and when we talk about MapReduce program, which is written in one Hadoop version, may not work with other versions. It might work or it might not. It depends on what are the dependencies, what is the compiler you're using, what programming language you have used, and what version of Hadoop you are working on. So these are the main differences between Apache Pig and MapReduce. What are the different ways of executing Pig script? So you could create a script file, store it in .pig or .text, and then you could execute it using the pig command. You could be bringing up the grunt shell, that is Pig's shell. Now that usually starts with MapReduce mode, but then we can also bring it up in a local mode, and we can also run Pig embedded as an embedded script in other programming language. So these are the different ways of executing your Pig script. Now, what are the major components of Pig execution environment? This is a very common question. Interviewers would always want to know different components of Hive, different components of Pig, even different components which are involved in Hadoop ecosystem. So when we want to learn about major components of Pig execution environment, here are some. So you have Pig scripts. Now that is written in Pig Latin using built-in operators and user-defined functions and submitted to the execution environment. That's what happens when you would want to process the data using Pig. Now there is a parser which does type checking and checks the syntax of the script. The output of parser is a DAG, direct acyclic graph. So look in Wikipedia for DAG. So DAG is basically a sequence of steps which run in one direction. Then you have an optimizer. Now this optimizer performs optimization using merge, transform, split, etc. It aims to reduce the amount of data in the pipeline. That's the whole purpose of optimizer. You have a internal compiler. So pig compiler converts the optimized code into a MapReduce job. And here user need not know the MapReduce programming model or how it works or how it is written. They all need to know about running the pig script, which would be internally converted into a MapReduce job. And finally, we have an execution engine. So MapReduce jobs are submitted to the execution engine to generate the desired results. So these are major components of pig execution environment. Now, let's learn about different complex data types in pig. Pig supports various data types. The main ones are tuple, bag, and map. What is tuple or tuple? As you might have heard, a tuple is an ordered set of fields which can contain different data types for each field. So in array, you would have multiple elements, but that would be of same types. List can also have different types. Your tuple is a collection which has different fields, and each field can be of different type. Now we could have an example as 1, 3 or 1, 3, a string or a float element, and all of that form a tuple. Bag is a set of tuples. So that's represented by curly braces. So you could also imagine this like a dictionary which has various different collection elements. What is a map? Map is a set of key value pairs used to represent data. So when you work in big data field, you need to know about different data types which are supported by pig, which are supported by Hive, which are supported in other components of Hadoop. So tuple, bag, map, array buffer. You can think about list, you can think about dictionaries, you can think about map, which is key value pair. So these are your different complex data types other than the primitive data types such as integer, character, string, boolean, float, and so on. Now, what are the various diagnostic operators available in Apache Pig? So these are some of the operators or options which you can give in a pig script. You can do a dump. Now, dump operator runs the pig Latin scripts and displays the result on the screen. So either I could do a dump and see the output on the screen, or I can even do a dump into and I could store my output in a particular file. So we can load the data using load operator in pig. And then pig also has different internal storage like JSON loader or pig storage, which can be used if you're working on specific kind of data. And then you could do a dump either before processing or after processing, and dump would produce the result. The result could be stored in a file or seen on the screen. You also have a describe operator. Now that is used to view the schema of a relation. So you can load the data and then you can view the schema of relation using describe operator. Explain, as we might already know, displays the physical, logical, and MapReduce execution plans. So normally in RDBMS, when we use explain, we would like to see what happens behind the scenes when a particular script or a query runs. So we could load the data using load operator as in any other case. And if we would want to display the logical, physical, and MapReduce execution plans, we could use explain operator. There is also an illustrate operator. Now that gives the step-by-step execution of sequence of statements. So sometimes when we would want to analyze our script to see how good or bad they are, or would that really serve our purpose, we could use illustrate. And again, you can test that by loading the data using load operator, and you could just use a illustrate operator to have a look at the step-by-step execution of the sequence of statements which you would want to execute. So these are different diagnostic operators available in Apache Pig. Now, if somebody asks, state the usage of group, order by, and distinct keywords in Pig script. So as I said, Pig is a scripting language. So you could use various operators. So group basically collects various records with the same key and groups the data in one or more relations. Here is an example. You could do a group data. So that is basically a variable, or you can give some other name and you can say group relation name by age. Now say I have a file where I have various fields, and one of the field is a relation name. So I could group that by a different field. Order by is used to display the contents of relation in a sorted order, whether ascending or descending. So I could create a variable called relation2, and then I could say order relation name 1 by ascending or descending order. Distinct basically removes the duplicate records, and it is implemented only on entire records. not on individual records. So if you would want to find out the distinct values and relation name field, I could use distinct. What are the relational operators in PIG? So you have various relational operators which help data scientists or data analysts or developers who are analyzing the data, such as cogroup, which joins two or more tables and then performs group operation on the join table result. You have cross. It is used to compute the cross product, that is a Cartesian product of two or more relations. For each is basically to do some iteration. So if it will iterate through tuples of a relation, generating a data transformation. So for example, if I say variable A equals, and then I load a file in A, and then I could create a variable called B, where I could say for each A, I would want to do something, say group. Join is to join two or more tables in a relation. Limit is to limit the number of output tuples or output results. Split is to split the relation into two or more relations. Union is to get a combination, that's it will merge the contents of two or more relations. And order is to get a sorted result. So these are some relational operators which are extensively used in PIG for analysis. What is the use of having filters in Apache PIG? Now, say for example, I have some data which has three fields: year, product, quantity, and this is my phone sales data. So filter operator could be used to select the required values from a relation based on a condition. It also allows you to remove unwanted records from data file. So for example, filter the products where quantity is greater than 1000. So I see that I have one row wherein, or multiple rows where the quantity is greater than 1000, such as 1500, 1700, 1200. So I could create a variable called A. I would load my file using pig storage. As I explained earlier, pig storage is an internal parameter which can be used to specify the delimiters. Now here my delimiter is comma. So I could say using pig storage as, and then I could specify the data type for each field. So year being integer, product being character array, and quantity being integer. Then B, I could say filter A, whatever we have in A, by quantity greater than 1000. So it's very concise, it's very simple, and it allows us to extract and process data in a simpler way. Now, suppose there is a file called test.txt having 150 records in Hdfs. So this is a file which is stored on Hdfs and it has 150 records, where we can consider every record being one line. And if somebody asks you to write a pig command to retrieve the first 10 records of the file, first we will have to load the data. So I could create a variable called test_data, and I would say load my file using pig storage, specifying the delimiter as comma, as, and then I could specify my fields, whatever fields our file have. And then I would want to get only 10 records, for which I could use the limit operator. So I could say limit on test data and give me 10 records. This is very simple, and we can extract 10 records from 150 records which are stored in the file on Hdfs. Now, we have learned on PIG, we have learned some questions on Hive. You could always look more in books like Programming in Hive or Programming in PIG and look for some more examples and try out these examples on a existing Hadoop setup. Now let's learn on HBase, which is a NoSQL database. Now HBase is a 4-dimensional database in comparison to your RDBMS, which usually are 2-dimensional. So RDBMS have rows and columns, but HBase has 4 coordinates. It has row key, which is always unique, column family, which can be any number, column qualifiers, which can again be any number per column family, and then you have a version. So these 4 coordinates make HBase a 4-dimensional key value store or a column family store, which is unique for storing huge amount of data and extracting data from HBase. There is a very good link which I would suggest everyone can look at if you would want to learn more on HBase, and you could just say HBase mapper. And this basically brings up a documentation which is from MapR, but then that's not specific to MapR. And you can look at this link, which will give you a detailed explanation of HBase, how it works, what are the architectural components, and how data is stored, and how it makes HBase a very powerful NoSQL database. So let's learn on some of the important or critical questions on HBase which might be asked by the interviewer in an interview when you're applying for a big data admin or a developer position role. So what are the key components of HBase? Now, as I said, this is one of the favorite questions of interviewers where they would want to understand your knowledge on different components for a particular service. HBase, as I said, is a NoSQL database, and that comes as a part of service with Cloudera or Hortonworks. And with Apache Hadoop, you could also set up HBase as an independent package. So what are the key components of HBase? HBase has a region server. Now, HBase follows the similar kind of topology like Hadoop. Now, Hadoop has a master process that is name node and slave processes such as data nodes and secondary name node. In the same way, HBase also has a master, which is HMaster, and the slave processes are called region servers. So these region servers are usually co-located with data nodes. However, it is not mandatory that if you have 100 data nodes, you would have 100 region servers. So it purely depends on admin. So what does this region server contain? So region server contains HBase tables that are divided horizontally into regions. Or you could say group of rows is called regions. So in HBase, you have two aspects. One is group of columns, which is called column family, and one is group of rows, which is called regions. Now these regions or these rows are grouped based on the key values, or I would say row keys, which are always unique. When you store your data in HBase, you would have data in the form of rows and columns. So group of rows are called regions, or you could say these are horizontal partitions of the table. So a region server manages these regions on the node where a data node is running. A region server can have up to 1,000 regions. It runs on every node and decides the size of region. So region server, as I said, is a slave process which is responsible for managing HBase data on the node. Each region server is a worker node or a worker process co-located with data node, which will take care of your read, write, update, delete request from the clients. Now, when we talk about more components of HBase, as I said, you have HMaster. So you would always have a connection coming in from a client or an application. What does HMaster do? It assigns regions. It monitors the region servers. It assigns regions to region servers for load balancing. And it cannot do that without the help of Zookeeper. So if we talk about components of HBase, there are three main components. You have Zookeeper, you have HMaster, and you have region server. Region server being the slave process, your HMaster being the master process, which takes care of all your table operations, assigning regions to the region servers, taking care of read and write requests which come from client. And for all of this, HMaster will take in help of Zookeeper, which is a centralized coordination service. So whenever a client wants to read or write or change the schema or any other metadata operations, it will contact HMaster. HMaster internally will contact Zookeeper. So you could have HBase set up also in high availability mode, where you could have a active HMaster and a backup HMaster. You would have a Zookeeper quorum, which is the way Zookeeper works. So Zookeeper is a centralized coordination service which will always run with a quorum of processes. So Zookeeper would always run with odd number of processes such as 3, 5, and 7. Because Zookeeper works on the concept of majority consensus. Now Zookeeper, which is a centralized coordination service, is keeping a track of all the servers which are alive, available, and also keeps a track of their status. For every server which Zookeeper is monitoring, Zookeeper keeps a session alive with that particular server. HMaster would always check with Zookeeper which region servers are available, alive, so that regions can be assigned to the region server. At one end, you have region server which are sending their status to the Zookeeper, indicating if they are ready for any kind of read or write operation. And at other end, HMaster is querying the Zookeeper to check the status. Now Zookeeper internally manages a meta table. Now that meta table will have information of which regions are residing on which region server and what row keys those regions contain. So in case of a read activity, HMaster will query Zookeeper to find out the region server which contains that meta table. Once HMaster gets the information of meta table, it can look into the meta table to find out the row keys and the corresponding region servers which contain the regions for those row keys. Now, if we would want to understand row key and column families in HBase, let's look at this, and it would be good if we could look this on an Excel sheet. So row key is always unique. It acts as a primary key for any HBase table. It allows logical grouping of cells and makes sure that all cells with the same row key are co-located on the same server. So as I said, you have 4 coordinates for HBase. You have a row key, which is always unique. You have column families, which is nothing but group of columns. And when I say column families, one column family can have any number of columns. So when I talk about HBase, HBase is 4-dimensional, and in terms of HBase, it is also called as a column-oriented database, which basically means that every row in one column could have a different data type. Now, you have a row key, which uniquely identifies the row. You have column families, which could be one or many, depending on how the table has been defined. And a column family can have any number of columns. Or I could say, for every row within a column family, you could have different number of columns. So I could say for my row 1, I could just have 2 columns such as name and city within the column family. For my row 2, I could have name, city, age, designation, salary. For my third row, I could have 1,000 columns, and all that could belong to one column family. So this is a horizontally scalable database. So column family consists of group of columns which is defined during table creation, and each column family can have any number of column qualifiers separated by a delimiter. Now, a combination of row key, column family, column qualifier such as name, city, age, and the value within the cell makes the HBase a unique 4-dimensional database. For more information, if you would want to learn on HBase, please refer this link, which is HBase Mapper, and this gives a complete HBase architecture. That is 3 components of name node, 3 components that is name node, region servers, and Zookeeper, how it works, how HMaster interacts with Zookeeper, what Zookeeper does in coordination, how are the components working together, and how does HBase take care of read and write. Coming back and continuing, why do we need to disable a table? So there are different table operations what you can do in HBase, and one of them is disabling a table. Now, if you would want to check the status of table, you could check that by is disabled and giving the table name, or is enabled and the table name. So the question is, why do we need to disable a table? Now, if we would want to modify a table, or we are doing some kind of maintenance activity, in that case, we can disable the table so that we can modify or change its settings. When a table is disabled, it cannot be accessed through the scan command. Now, if we have to write a code to open a connection in HBase, now to interact with HBase, one could either use a graphical user interface such as Hue, or you could be using the command line HBase shell, or you could be using HBase admin API if you are working with Java, or say HappyBase if you are working with Python, where you may want to open a connection with HBase so that you can work with HBase programmatically. In that case, we have to create a configuration object, that is configuration myconf, and then create a configuration object. And then you can use different classes like HTableInterface to work on a new table. You could use HColumn qualifier and many other classes which are available in HBase admin API. What does replication mean in terms of HBase? So HBase, as I said, works in a cluster way. And when you talk about cluster, you could always set up a replication from one HBase cluster to other HBase cluster. So this replication feature in HBase provides a mechanism to copy data between clusters or sync the data between different clusters. This feature can be used as a disaster recovery solution that provides high availability for HBase. So if I have HBase cluster 1, where I have one master and multiple region servers running in a Hadoop cluster, I could use the same Hadoop cluster to create a HBase replica cluster, or I could have a totally different HBase replica cluster where my intention is that if things are changing in a particular table in cluster 1, I would want them to be replicated across different clusters. So I could alter the HBase table and set the replication scope to 1. Now, a replication scope of 0 indicates that table is not replicated. But if we set the replication to 1, we basically will have to set up a HBase cluster where we can replicate HBase tables data from cluster 1 to cluster. So these are the commands which can be used to enable replication and then replicate the data of table across clusters. Can we import and export in HBase? Of course we can. It is possible to import and export tables from one HBase cluster to other HBase cluster or even within a cluster. So we can use the HBase export utility, which comes in this particular package. Give a table name and then a target location. So that will export the data of a HBase table into a directory on Is Hdfs. Then I could create a different table which would follow some kind of same definition as the table which was exported, and then I could use import to import the data from the directory on Is to my table. If you would want to learn more on HBase import and export, you could look at HBase import operations. Let's search for the link, and this is the link where you could learn more about HBase import export utilities, how you could do a bulk import, bulk export, which internally uses MapReduce, and then you could do a import and export into HBase tables. Moving further, what do we mean by compaction in HBase? Now, we all know that HBase is a NoSQL database which can be used to store huge amount of data. However, whenever a data is written in HBase, it is first written to what we call as write ahead log and also to memstore, which is write cache. Now, once the data is written in wall and your memstore, it is offloaded to form an internal HBase format file, which is called H file. And usually these H files are very small in nature. So we also know that Hdfs is good when we talk about few number of larger files in comparison to large number of smaller files due to the limitation of name nodes memory. Compaction is process of merging HBase files, that is these smaller H files, into a single large file. This is done to reduce the amount of memory required to store the files and number of disk seeks needed. So we could have a lot of H files which get created when the data is written to HBase, and these smaller files can then be compacted through a major or minor compaction, creating one big H file, which internally would then be written to Hdfs and Hdfs format of blocks. That is the benefit of compaction. There is also a feature called Bloom filter. So how does Bloom filter work? So Bloom filter or HBase Bloom filter is a mechanism to test whether a H file contains a specific row or a row column cell. Bloom filter is named after its creator, Burton Howard Bloom. It is a data structure which predicts whether a given element is a member of a set of data. It provides an in-memory index structure that reduces the disk reads and determines the probability of finding a row in a particular file. This is one of very useful features of HBase, which allows for faster access and avoids disk seeks. Does HBase have any concept of namespace? So namespace is when you have similar elements grouped together. So namespace, yes, HBase supports namespace. So namespace is a logical grouping of tables, analogous to a database in RDBMS. So you can create HBase namespace to the schema of RDBMS database. So you could create a namespace by saying create namespace and giving it a name. And then you could also list the tables within a namespace. You could create tables within a specific namespace. Now, this is usually done in production environment where a cluster might be multi-tenant cluster and there might be different users of the same NoSQL database. In that case, admin would create specific namespace, and for specific namespace, you would have different directories on HDFS, and users of a particular business unit or a team can work on their HBase objects within a specific namespace. This is a question which is again very important to understand about the writes or reads. So how does write ahead log wall help when a region server crashes? Now, as I said, when a write happens, it will happen into memstore and wall, that is your edit log or write ahead log. So whenever a write happens, it will happen in two places, memstore, which is the write cache, and wall, which is an edit log. Only when the data is written in both these places and based on the limitation of memstore, the data will be flushed to create an HBase format file called hfile. These files are then compacted and created into one bigger file, which will then be stored on SDFS. And SDFS data, as we know, is stored in the form of blocks on the underlying data nodes. So if a region server hosting a memstore crashes, now where is region server running? That would be co-located with data node. So if a data node crashes, or if a region server which was hosting the memstore write cache crashes, data in memory, the data that in memory which was not persisted, is lost. Now, how does HBase recover from this? As I said, your data is written into wall and memstore at the same time. HBase recovers against that by writing to wall before the write completes. So whenever a write happens, it happens in memstore and wall at the same time. HBase cluster keeps a wall to record changes as they happen, and that's why we call it as also an edit log. If HBase goes down or the node that goes down, the data that was not flushed from memstore to hfile can be recovered by replaying the write ahead log, and that's the benefit of your edit log or write ahead log. Now, if we would have to write HBase command to list the contents and update the column families of a table, I could just do a scan, and that would give me complete data of a table. If you are very specific and if you would want to look at a particular row, then you could do a get table name and then give the row key. However, you could do a scan to get the complete data of a particular table. You could also do a describe to see what are the different column families. And if you would want to alter the table and add a new column family, it is very simple. You can just say alter, give the HBase table name, and then give your new column family name, which will then be added to the table. What are catalog tables in HBase? So as I mentioned, your Zookeeper knows the location of this internal catalog table, or what we call as the meta table. Now, catalog tables in HBase have two tables. One is HBase meta table and one is -root. The catalog table HBase meta exists as an HBase table and is filtered out of HBase shell's list command. So if I give a list command on HBase, it would list all the tables which HBase contains, but not the meta table. It's an internal table. This meta table keeps a list of all regions in the system and location of HBase meta stored in Zookeeper. So if somebody wants to find out or look for particular rows, they need to know the regions which contain that data, and those regions are located on region server. To get all this information, one has to look into this meta table. However, we will not be looking into meta table directly. We would just be giving a write or a read operation. Internally, your HBase master queries the Zookeeper. Zookeeper has the information of where the meta table exists, and that meta table which is existing on region server contains information of row keys and the region servers where those rows can be found. Your root table keeps a track of location of the meta table. What is hotspotting in HBase and how to avoid hotspotting? Now, this is a common problem, and always admin guys or guys who are managing the infrastructure would think about it. So one of the main idea is that HBase would be leveraging the benefit of HDFS. your all read and write requests should be uniformly distributed across all of the regions and region servers. Otherwise, what's the benefit of having a distributed cluster? So you would have your data stored across region servers in the form of regions, which are horizontal partitions of the table. And whenever read and write requests happen, they should be uniformly distributed across all the regions in the region servers. Now, hotspotting occurs when a given region serviced by a region server receives most or all of read and write requests, which is basically a unbalanced way of read-write operations. Now, hotspot can be avoided by designing the row key in such a way that data being written should go to multiple regions across the cluster. So you could do techniques such as salting, hashing, reversing the key, and many other techniques which are employed by users of HBase. We need to just make sure that when the regions are distributed across region servers, they should be spread across region servers so that your read and write request can be satisfied from different region servers in parallel rather than all read and write requests hitting the same region server, overloading the region server, which may also lead to the crashing of a particular region server. So these were some of the important questions of HBase, and then there are many more. Please refer to the link which I specified during my discussion, and that gives you a detailed explanation of how HBase works. You can also look into HBase Definitive Guide by O'Reilly or HBase in Action, and these are really good books to understand about HBase internals and how it works. Now that we have learned on Hive, which is a data warehousing package, we have learned on Pig, which is a scripting or a scripting language which allows you to do data analysis, and we have learned some questions on a NoSQL database. Just note it that there are more than 225 NoSQL databases existing in market. And if you would want to learn and know about more NoSQL databases, you can just go to Google and type NoSQL databases.org, and that will take you to the link which is for NoSQL databases, and this shows there are more than 225 NoSQL databases existing in market, and these are for different use cases used by different users and with different features. So have a look at this link. Now, when you talk about data ingestion, so let's look at data ingestion, and this is one good link which I would suggest to have a look at, which lists down around 18 different ingestion tools. So when you talk about different data ingestion tools, some are for structured data, some are for streaming data, some are for data governance, some are for data ingestion and transformation, and so on. So have a look at this link, which also gives you a comparison of different data ingestion tools. So here, let's learn about some questions on Scoop, which is one of the data ingestion tools mainly used for structured data, or you could say data which is coming in from RDBMS, or data which is already structured and you would want to ingest that. You would want to store that on HDFS, which could then be used for Hive, which could be used for any kind of processing using MapReduce or Hive or Pig or Spark or any other processing frameworks, or you would want to load that data into, say, Hive or HBase tables. Scoop is mainly for structured data. It is extensively used when organizations are migrating from RDBMS to a big data platform, and they would be interested in ingesting the data, that is doing import and export of data from RDBMS to HDFS or vice versa. So let's learn about some important questions on Scoop, which you may be asked by an interviewer when you apply for a big data related position. How is Scoop different from Flume? So this is a very common question which is asked. Scoop, which is mainly for structured data. So Scoop works with RDBMS. It also works with NoSQL databases to import and export data. So you can import data into HDFS. You can import data into data warehousing packets such as Hive directly, or also in HBase. And you could also export data from Hadoop ecosystem to your RDBMS. However, when it comes to Flume, Flume is more of a data ingestion tool which works with streaming data or unstructured data. So data which is constantly getting generated, for example, log files or metrics from server or some chat messenger and so on. So if you are interested in working on capturing and storing the streaming data in a storage layer such as Hdfs or Hdbase, you could be using Flume. There could be other tools also like Kafka or Storm or Chukwa or Samza, NiFi and so on. Scoop, however, is mainly for structured data. Your loading data in Scoop is not event driven, so it is not based on event. It basically works on data which is already stored in RDBMS. In terms of Flume, it is completely event driven. That is, as the messages or as the events happen, as the data is getting generated, you can have that data ingested using Flume. Scoop works with structured data sources, and you have various Scoop connectors which are used to fetch data from external data structures or RDBMS. So for every RDBMS such as MySQL, Oracle, DB2, Microsoft SQL Server, you have different connectors which are available. Flume, it works on fetching streaming data such as tweets or log files or server metrics from your different sources where the data is getting generated. And if you are interested in not only ingesting that data, which is getting generated in a streaming fashion, but if you would be interested in processing the data as it arrives. Scoop can import data from RDBMS onto Hdfs and also export it back to RDBMS. Flume is then used for streaming data. Now you could have one-to-one, one-to-many, or many-to-one kind of relation. So in terms of Flume, you have components such as your source, sink, and channel. That's the main difference between your Scoop and Flume. What are the different file formats to import data using Scoop? Well, there are lots and lots of formats in which you can import data into Scoop. When you talk about Scoop, you can have delimited text file format. Now that's the default import format. It can be specified explicitly using as text file argument. So when I want to import data from an RDBMS, I could get that data in Hdfs using different compression schemes or in different formats using the specific arguments. So I could specify an argument which will write string-based representation of each record to output files with delimiters between individual columns and rows. So that is the default format which is used to import data using Scoop. So to learn more about your Scoop and different arguments which are available, you can click on scoop.apache.org. You can look into the documentation, and I would suggest choosing one of the versions and looking into the user guide. And here you can search for arguments and look for specific control arguments which show how you can import data using Scoop. So here we have common arguments, and then you also have import control arguments, wherein we have different options like getting data as Avro, as sequence file, as text file, or Parquet file. These are different formats. You can also get data in default compression scheme, that is gzip, or you can specify compression codec, and then you can specify what compression mechanism you would want to use when you're importing your data using Scoop. When it comes to default format for Flume, we could say sequence file, which is a binary format that stores individual records in record-specific data types. So these data types are manifested as Java classes, and Scoop will automatically generate these data types for you. So Scoop does that. When we talk about your sequence file format, in terms of your Scoop, you could be extracting storage of all data in binary representation. So as I mentioned, you can import data in different formats such as Avro, Parquet, sequence file, that is binary format or machine readable format. And then you could also have data in different compression schemes. Let me just show you some quick examples here. So if I look in the content, and here I could search for a Scoop based file where I have listed down some examples. So if I would want to use different compression schemes, here are some examples. Have a look at these. So I'm doing a Scoop import. I'm also giving an argument so that Scoop which also triggers a map reduce job, or I would say map only job. So when you run a scoop import, it triggers a map only job. No reduce happens here. And you could specify this parameter or this argument on the command line mapreduce.framework.name so that you could run your map only job in a local mode to save time, or that would interact with yarn and run a full-fledged map only job. We can give the connection and then connect to whatever RDBMS we are connecting, mentioning the database name, give your username and password, give the table name, give a target directory, or it would create a directory same as the table name, which would work only once. And then I could say -z to get data in a compressed format, that is gzip, or I could be specifying compression codec, and then I could specify what compression codec I would want to use, say snappy, bzip, lz4, default. I could also run a query by giving a scoop import. And when I'm specifying a query, if you notice, I've not given any table name because that would be included in the query. I can get my data as a sequence file format, which is a binary format, which will create a huge file. So we could also have compression enabled. And then I could say the output of my map job should use a compression at record level for my data coming in sequence file. So sequence file or a binary format supports compression at record level or at block level. I could get my data in an Avro file where data has embedded schema within the file, or a Parquet file also. So these are different ways in which you can set up different compression schemes, or you can even get data in different formats, and you could be doing a simple scoop import for these. Looking further, what is the importance of eval tool in scoop? So there is something called as eval tool. So scoop eval tool allows users to execute user-defined queries against respective database servers and preview the result in the console. So either I could be running a straight away query to import the data into my Is Hdfs, or I could just use scoop eval, connect to my external RDBMS, specify my username and password, and then I could be giving in a query to see what would be the result of the query which we intend to import. Now, let's learn about how Scoop imports and exports data between RDBMS and Hdfs with its architecture. So RDBMS, as we know, has your database structures, your tables, which all of them are logical. And internally, there is always metadata which is stored. Your Scoop import connects to an external RDBMS, and for this connection, it uses an internal connector jar file which has a driver class. So that's something which needs to be set up by admin, but they need to make sure that whichever RDBMS you intend to connect to, they need to have the JDBC connector for that particular RDBMS stored within the Scoop lib folder. So Scoop import gets the metadata, and then for your Scoop command, it converts that into a map only job, which might have one or multiple map tasks. Now that depends on your Scoop command. You could be specifying that you would want to do a import only in one task or in multiple tasks. These multiple map tasks will then run on a section of data from RDBMS and then store it in Hdfs. So at high level, we could say Scoop will introspect database to gather the metadata. It divides the input data set into splits, and this division of data into splits mainly happens on primary key column of the table. Now, if somebody might ask, what if my table in RDBMS does not have a primary key column? Then when you're doing a Scoop import, either you will have to import it using one mapper task by specifying -m equals 1, or you would have to say split by parameter to specify a numeric column from RDBMS. And that's how you can import the data. Let me just show you a quick example on this. So I could just look in again into the Scoop command file, and here we could be looking at an example. So if you see this one, here we are specifying -m equals 1, which basically means I would want to import the data using one map task. Now in this case, whether the table has a primary key column or does not have a primary key column will not matter. But if I say a -ms6, where I'm specifying multiple map tasks to be imported, then this will look for a primary key column in the table which you are importing. Now, if the table does not have a primary key column, then I could be specifying a split by and then specify the column so that the data could be split into multiple chunks and multiple map tasks could take it. Now, if the second scenario is your table does not have a primary key column and it does not have a numeric column on which you could do a split by, in that case, and if you would want to use multiple mappers, you could still say split by on a textual column, but you will have to add this property so that it allows splitting the data which is non-numeric. All of these options are given in the scoop.apache.org link. Going further, how Scoop imports and exports data between RDBMS and Is with its architecture. So as I said, it submits the map only job to the cluster, and then it basically does a import or export. So if we are exporting the data from Is in that case, again, there would be a map only job. It would look at multiple splits of the data which is existing, which your map only job would process through one or multiple map task and then export it to RDBMS. Suppose you have a database testDB in MySQL. If somebody asked you to write a command to connect this database and import tables to Scoop. So here is a quick example as I showed you in the command file. So you could say scoop import. This is what we would want to do. You connect using JDBC. Now this will only work if the JDBC connector already exists within your scoop lib directory. Admin has to set up that so you can connect to your RDBMS. You can point to the database. So here our database name is test_db. I could give username and then either I could give password on the command line or just say capital P so that I could be prompted for the password, and then I could give the table name which I would want to import. I could also be specifying --m and specify how many map tasks do I want to use for this import, as I showed in previous screen. How to export a table back to RDBMS? Now for this, we need the data in a directory on HDFS. So for example, there is a departments table in retail database, which is already imported into Scoop, and you need to export this table back to RDBMS. So this is the content of the table. Now create a new department table in RDBMS. So I could create a table specifying the column names, whether that supports null or no, if that has a primary key column, which is always recommended. And then I can do a scoop export. I can connect to the RDBMS, specifying my username and password, specify the table into which you want to export the data, and then you give export directory pointing to a directory on HDFS which contains the data. This is how you can export data into table. Seeing example on this. So I could again look into my file, and here I have an example of import. This is where you are importing data directly into Hive, and you have scoop import where you are importing data directly into HBase table, and you can then query your HBase table to look at the data. You could also do a export by running your map only job in a local mode, connecting to the RDBMS, specifying your username, specifying the table where you would want to export, and the directory on HDFS where you have kept the relevant data. This is a simple example of export. Looking further, what is the role of JDBC driver in Scoop setup? So as I said, if you would want to use Scoop to connect to an external RDBMS, we need the JDBC ODBC connector jar file. Now, one or admin could download the JDBC connector jar file and then place the jar file within the Scoop lib directory wherever Scoop is installed. And this JDBC connector jar file contains a driver. Now, JDBC driver is a standard Java API which is used for accessing different databases in RDBMS. So this connector jar file is very much required, and this connector jar file has a driver class, and this driver class enables the connection between your RDBMS and your Hadoop structure. Each database vendor is responsible for writing their own implementation that will allow communication with the corresponding database, and we need to download the drivers which allow our scoop to connect to external RDBMS. So your JDBC driver alone is not enough to connect to scoop. We also need connectors to interact with different databases. So a connector is a pluggable piece that is used to fetch metadata and allow scoop to overcome the differences in SQL dialects. So this is how connection can be established. So normally your admins would, when they are setting up Scoop and Hadoop, they would download, say, MySQL JDBC connector, and this is how they would go to the MySQL connectors. If you are connecting to MySQL, similarly for your other RDBMS, you could be, say, going in here, you could be looking for a previous version, depending, you could be going for platform independent, and then you could be downloading the connector jar file. Now, if you untar this jar file, you would see a MySQL connector jar. And if we look in com.mysql.jdbc.driver, so this is the package which is within the connector jar file, and this has the driver class which allows the connection of your scoop with your RDBMS. So these things will have to be done by your admin so that you can have your scoop connecting to an external RDBMS. Now, how do you update the columns that are already exported? So if I do a export and I put my data in RDBMS, can I really update the columns that are already exported? Yes, I can, using a update key parameter. So scoop export command remains the same. The only thing I will have to specify now is the table name, your fields terminated by if you have a specific delimiter, and then you can say update key and then the column name. So this allows us to update the columns that are already exported in RDBMS. What is CodeGen? So scoop commands translate into your MapReduce job or map only job. So CodeGen is basically a tool in Scoop that generates data access objects, DAO, Java classes that encapsulate and interpret imported records. So if I do a Scoop CodeGen connect to an RDBMS using my username and give a table, this will generate a Java code for employee table in the test database. So this CodeGen can be useful for us to understand what data we have in this particular table. Finally, can Scoop be used to convert data in different formats? I think I already answered that, right? If no, which tools can be used for this purpose? So Scoop can be used to convert data in different formats, and that depends on the different arguments which you use when you do a import, such as Avro file, Parquet file, binary format with record or block level compression. So if you're interested in knowing more on different data formats, then I think I can suggest a link for that. And we can say Hadoop formats. I think it is Tech, Maggie, Avro, Parquet. Let's see if we can find out the link. Tech, Maggie. Yeah, this is a very good link which specifies or talks about different data formats which you should know, such as your text file format, different compression schemes, how is data organization, what are the common formats, what do you have in text file, structured, binary, sequence files with compression, without compression, what is record level, what is block level, what is a Avro data file, what is a what is a Parquet data file or a columnar format, and other formats like ORC, RC, and so on. So please have a look at this.
So with this, we have come to the end of this basics of big data. If you have found this session informative and interesting, please consider subscribing to our YouTube channel. Let us know your queries in the comment section below. Our experts will happily answer you. Until next time, thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.